Hello everyone. So today's session is going to be a little bit longer that I assume, and everybody should be prepared for that. So last session we basically left our session where we were discussing about column major and row major orders. I said that there are two orders in which you can store the arrays. So first for that we have to understand the memory layout. If you see memory layout, so I said think memory as just run of these bits. Okay, like this. So this is run of bits. Okay, and I said memory is something which is called as word addressable. Word addressable means that each word is addressed. A word can be of multiple bytes also. So usually for the sake of simplicity we say that let's consider everything as byte addressable. So what is the meaning of that? That means that each byte is being addressed. Okay, if you have a memory of, let's suppose, 1 kilobyte, so that means you should have 1 kilo addresses. That means 1000 addresses. Okay, and or 1024, howsoever you define kilo in terms of computer science, we say 1 kilo means 1024, that is 2 to the power 10. Okay, these many addresses should be available because you have these many bytes if the memory is byte addressable. Now if you see the layout of this memory, so memory is just a run of bits. So these bits can be realized physically by any system. So usually we have two level systems, like in our secondary storage, in hard drives as SSDs. So these are in hard drive we have magnetic disks, okay, or in maybe RAM we have these electric impulses. So that is the physical realization of these bits. Now if you see an array, so that we are seeing from past two sessions, so array is defined like we have multi-dimensional arrays. So 1D array, it's easy to visualize it. If we have an array 1 2 3, so if we have memory like this, so we can start at any point and we'll store it at like 1 2 3. This is how we store it. But the problem arises when we have these multi-dimensional arrays. So by multi-dimensional I mean that you have more than one dimension, 1 2 3. If this is an array, 4 5 and 6. Okay, now if you have to store this array, so I told there are two orders. One is called as row major order and there is called as column major order. Yesterday we discussed in detail. I'm just covering that up so that everybody is on the same page. Okay, so what we'll do in this row major order, we take everything row wise. So this is one row, so we'll take 1 2 and 3, then we'll take second row, okay, 4 5 and 6. Okay, this is how we'll store. So in the column major order we'll do something like we'll take each column at a time. Okay, so in column major order this is row major order. So in column major order what we do is we'll take column first. We'll take this 1 4, this is the first column, okay, this column, and then we'll take this 2 5, and then we'll store this 3 6 3 6, and this is called as column major order. So these are two major orders. So I said these addresses accordingly change. So we said that if you want to find an address, you have a base address and plus number of elements to navigate, and then multiplied by b. B basically means if the memory is how much memory is taken by the each element. So that was the formulation, and number of elements, these things change according to row major and column major order. Okay, I hope that everybody has seen the previous lecture. So this is what we discussed so far. I think there is a question. Is there a question? No. Okay, let's go ahead.
I have a question.
Yes,
So
yes.
in both the cases, the row major and column major, maybe I missed because I wasn't here. So I would like to ask: is there any difference in memory architecture, or it just the metadata that is stored
So
that
so
it's
usually that's what I said. The simplest assumption we can make is memory is just run. So there is
Mhm.
in the architecture there won't be changes, but in the metadata we will change. That's why we'll change this formulation. So here I'll say that there are strides that will get changed, and that we'll see in the NumPy today. Okay, I hope that at least you are able to get till this point. So because now we'll translate this into NumPy. Okay. Now we saw that these NumPy arrays, they have attributes. So as the attribute was d type, what's the data type of the element. So there are different attributes that these NumPy arrays have. So there are some other attributes by the help of which you can basically see some what you call as flags. Okay, there are some flags which you can see. So what these flags are, so they'll tell you a lot of details about how these things are stored in the memory. And if you just print these flags, and probably I should print that to show you that. Okay, let me just switch to the coding window to show you that. Give me a sec so that I set up the coding window. So what I said is I said there are some flags. Okay, if you see there are some flags. So what we can do is in NumPy we can print these flags and then we'll see what these flags are. So if I create a general NumPy array, any array, let's suppose I'll just create a two-dimensional array maybe. So I'll say import NumPy as np, and then what I'll say is I'll say array that's equal to np dot array. So then I'll create a 2D array. Okay, 2D array of 1 comma 2 comma 3. This is the first element, and then I'll say 4 comma 5 comma 6. Okay, if I print this, so everybody should expect that the result that we'll get is a two-dimensional array. Print array. So if I just save this, if I go here and say Python test9.py, so here you can see that 1 2 3 4 5 6, this is a two-dimensional array. Okay, and there are attributes also. I told you there are attributes like dot shape, dot size, and things like that. So the one of the attributes is dot flags. So what you can do is you can print flags. If I write dot flags, so here if I print this, you can see there are these flags: C continuous, F continuous, own data, writable, aligned. So let's have a small discussion on these things, okay, and what these things mean. So I'll pin myself so that I can see the screen and I can see if you have questions. Okay, so the first thing that you can see over here is this C continuous. Okay, yesterday I said that if you have the C continuous, what's the meaning of this? So it means is it in the C order? C order basically means the row major order, because C language, it stores these arrays into row major order. I'll just maybe just close this. So the first attribute that you saw is C continuous. So that was the first flag, C continuous. So this flag basically tells us, okay, is this array that you have, if this is true, because this is a boolean value, it will be true or false. If this is true, that means it is stored in C order. C order basically means as C stores the data, stores this array. So C stores in row major order. That's what it says. Okay, that means the array data is stored in a single continuous block of memory in a row major order, or we can call it C style order. So C style basically means however C stores the memory. That's row by row. This is the first flag. Okay, again bring back the window. So this is that C continuous, and then if you see the second flag over here, that's F continuous. F continuous means Fortran. Okay, Fortran basically is a language which stores the data into column major order. So this is that. So I'll write it here. So we have F continuous. F continuous means that are you storing this array into the row major order? That is, as the Fortran, this is a language, it stores the arrays into row major order. Are you storing like this? So these are two flags. So first is C continuous. So here we have C continuous, this is the flag, and then we have F continuous, the two flags. And then we have this own data. Own data means, does this data belong to the array? Is it the original array? And because we will discuss about what views and copies are, there's a difference between own data. Okay, so there is this flag now and the flag. So and the flag, if you see, is this own data. Own data basically means, is it a viv or a copy? That means does this data belong to the array? So here we have this array, does it actually belong to it? Okay, that is the meaning of own data. Then we are saying, is it writable? Can we write onto this? Okay, so is this can we if it is read and write? So otherwise, if it is let's suppose set it as false, so we can say that this is only read only array. We can just read from the array, and we cannot write it. Okay, then we have the align. So what is the meaning of align? The data and the strides are aligned memory for the faster access. Because what I said is, in NumPy, you don't use explicit for loops. There is something called as vectorization. So what they do is they'll have these strides. I'll discuss briefly about strides in next couple of minutes. So what I'm saying is the data and the strides, they're aligned in the memory, so that we access it faster by using the CPU. Then we are saying update. Write back if copy. So that means if this flag is set, that means if you wrote it back, then create a copy. Okay, I actually told you there's a concept called as cow. Cow basically means that when you change something, modify something, copy on write. So okay, you are making a copy when you write. So here if you see, this is write back if copy. If the data is copied, or if something is done, then write back the data. And these are the flags. Okay, but the two interesting flags we have here. One is this C and F, and the other one more thing that we have is this own data. Okay, because we'll create views, and then we'll also see strides. Okay, these are the flags. Okay, now if you see here, it is C continuous. That means this is stored in row major order. That's one row is stored at a time. Okay, first row is stored, then we take another row, we store it into that continuous memory. So now the point is, okay, we'll see about strides. Okay, if it is now stored in the row major order, so I wanted to show you what strides mean and what are the implications of having strides. So there is again one more attribute. I can just print it strides. So I can say print array dot strides. Okay, so if I just print this, so you can see whatever after flags, this is the strides. So it is a tuple. So here if you see, there is something as 24 and 8. So what is the meaning of this? So this means, this 24 and 8 means to move to the next row, that is along the dimension 0, because dimension 0 means next row, you need to move 24 bytes. Okay, that's what it says. you need to move 24 bytes. Okay, because we have three elements. So we have this three element, that's 1, 2 and 3. These are three elements that we have. So in order to move to the next row, the first point is that we have to move 24 bytes. Okay, to move to the next element in a row, okay, to move to the next element we just need 8 bytes. Okay, that's along the dimension 1. If you need to choose, you need to move 8 bytes. That's what these two things say. If we make a 3D array, so it will be a tuple of 3 dimensions. So that is what these 24 and 8 means. So these are the strides. Okay, I suppose you understood strides. So what I mean by strides is, so we have a tuple like this, 24 comma 8. So this is the tuple that is over here. So what is the first thing saying? The first thing is saying, because as this is stored in a row major order. So what is the meaning of row major order? So row major order means like this. So it is stored like this: 1, 2, 3, and then we have 4, 5 and 6. This is how it is stored. Okay, so in order to move into the next row, because now you know the layout is like this: 1 comma 2 comma 3, and then we have 4 comma 5 comma 6. This is actually the 2D, and here you know that this is called as dimension or axis 0, and this is called as axis 1. Okay, so if you move along this dimension 0 or axis 1, okay, so what I have to do is, if I want to jump towards this element, so I should move 24 bytes. Why? Because each of this integer is taking 8 bytes. So here if you see, this is 8, this is 8, this is 8, so I have to move 24 bytes to go to this 4. Okay, that's what this first dimension of this tuple is saying. 24 basically means in order to go to the next row directly, so what you should do is, you should go 24 bytes 24 bytes towards forward, and then you will find that element. So what is this 8 saying? This 8 is saying, if you go on this dimension 1, axis 1, that is if you want to move towards the other element, so you just need to go to 8 elements. Okay, so to justify this, let me show you another example. Okay, here we have created 1, 2, 3, 4. So we'll just add one more thing, that is -1, and then we'll add one more element over here, maybe 0, something like this. So now hopefully this stride should get changed, because in order to move towards the next row, what you should do is, you should now have 32, you should move 32 bytes. Okay, this 8 will remain as it is. So now if you see, is now the value is 32,8. So how many of you understood strides? Pretty easy concept, nothing rocket science. Anyone, rocket science is not difficult, I'm saying just as a phrase. Okay, so I hope that this is okay for everybody. Why I introduced these things, and now I'll tell you a fundamental question. I'll tell you why I introduced these flags, why I introduced these strides, because there is a lot of things that you can do only with this now. Okay, just let me click on this and close the VS Code. So why is this strides, and why are these needed? Okay, if you now have the memory, now you saw that we don't have to change the data. As Mahmoud asked the question, that does the memory architecture change? No, it does not. Okay, so what NumPy does is, and what maybe not just NumPy is a generic concept, what other frameworks, or maybe if you are building a piece of code, what you should do. Let's suppose you have an array like this. You have 1 comma 2 comma 3 comma 4 comma 5 comma 6. So this is a one dimensional array, 1D array. Now you know that in the memory it will be stored something like this: 1, 2, 3, 4, 5 and 6. This is how it will be stored, and because it's a 1D array. So now what if you want to make it 2D array? You will operate on it, you will perform reshape. Okay, you will have a reshape operation, and you will say, okay, convert this into 3 cross 3 matrix, maybe 2 cross 3 rather. 2 cross 3, have 2 rows and then 3 columns, and convert this. But you know that the one thing that you can do is, you need not to create copies. What you can do is, you can just have this memory layout as it is, just change the strides. Okay, if you change the initially strides, what should be strides? So let's do this. Okay, let's go to the code window and see how these strides affect. Okay, because that's the most efficient way. If you just change strides, that's metadata about it, and you are not changing the underlying architecture, underlying memory architecture that we have, and you are just changing that. Okay, let's see what will happen that. So here we have this array. Okay, let's just create an array which has maybe 0 to suppose 9 elements, or maybe 6 elements. So I'll say np arange. Arange is a function in which I'll create 1D arrays. So I'll create 6 elements. Okay, so now if I print this array, it should be having elements from 0 to 5. So print array. If I now print this, so obviously the output should be 0, 1, 2, 3, 4, 5, 6. Now what I'm doing is, I'm printing array.strides also. You can see strides is 8. Okay, that 8 means that it's just a single row. Okay, in order to go to the next, let's suppose element, it will just show one dimension. Okay, one dimension. In order to go to the next element, you just have to move 8 bytes, and to reach this one, or from the 1 to reach 2, you have to move 8 bytes. So what if I do this? What if I say array of new? There's a new array. I'll reshape the previous array. Okay, this is array dot reshape. Okay, in this reshape, what I'll do is I'll reshape into 2 comma 3. I'll say that make 2 rows and 3 columns. So now what will happen is 0 1 2 will be the first row and 3 4 5 will be the second row. If I just print it, let's suppose I'll print this array now. Print array of new. Okay, now you can see that there is this 0 1 2 3 4 5. This is this line. Okay, this line is printing. Now I again want to print the same things for this. I again want to print these two things, the strides and the flags. Okay, but this is our array new. Okay, and then we have array new over here also. Okay, now you can see the change. Okay, if you see it over here, so if you see it over here, so now you see that the thing that got changed is this. So own data is false. Okay, own data is false. Here it was true. Okay, now again if you see this, the main important thing is this. If you see strides got changed. Okay, this strides, it was initially 8 comma this, and then it changed to 24 comma 8 because dimensions got changed. Okay, that means the memory layout that we earlier had. So even own data basically it is not its own data. Okay, this is just a view. This is called as view. I'll go in detail what views and copies are, but here if you see that this array new was not created as a new object. It doesn't have its own memory. What it basically does is it will use the original memory layout. Whatever original memory layout there was. So if you see it over here, so this this array probably. So the first array that we have created, so it will only use that. So that array will be used, and we have reshaped. The only point, the only most important thing that we changed is the stride. Okay, how do you look at this now? Okay, if you look it in a certain way, it is a 2D array. If you look it in a certain way, it's a 1D array. Okay, that is how do we change, and we make these views rather than copies. Okay, so that means if I change something in the array new, so that those changes should also happen in the array. Okay, that's the meaning of the view. So if I go back to the coding window, if I show you that, so let's suppose now this array new is there. If I made some change, okay, print array new, and this is my array new, and I'll just close these strides and I won't print them. Okay, this is my array, print array, and this is my array new. So if you see the two arrays, one is 0 to 5 and one is the layout is different because the how they are portrayed to the user is different, but underlying memory is the similar. So what I said is this is not the actual data that you have. It's basically the same data, but it is presented you in a different format, in a different view. So now what I can do is, in order to prove this point, I showed you flags. Okay, maybe you don't trust flags. So what I can do is, I'll make some change in the original array, or maybe I'll change something in the new array, and I should see if that change happened in this array. So what I can do is, I'll change it after this. So I'll say array maybe of third element is some 25. Okay, that means that at index 3, if I'm saying that I have changed 35, that means 0, 1, 2, and 3. At this index, let's suppose, at this index, I should get 25. So what I'm saying is, if this was the same memory layout, if this memory was similar and just strides was changed, that means this should also change. So now doing that, you can see this 0, 1, 2, 25, 4, 5, and here 25 also got changed. So this proves the fact that the memory, underlying memory is basically similar. So what this reshape function did, it did nothing. It basically changed the strides. Think from a implementation perspective. If you have to implement it, one method would have been, okay, if I am reshaping the array, okay, do one thing, take the array, copy the data, and then put the memory layout, do this column measure, row measure, or howsoever you want to do. It was a whole headache. Okay, how we optimized it? We said, okay, can we just add one more data about it? We can just add strides. Okay, in what those strides does is they'll tell you how much to move in order to go to the next row. Let's suppose if it is in the row measure order, and how much for the along the different dimensions. Okay, if we just thought it. Maybe it is a natural idea also. Okay, now you saw that we somehow reuse the memory. We use the memory and we optimized it, and by this reshape function, we gave it to the user as user wanted it, and then you can manipulate it as the user wants. Okay, any questions still here? Any questions? So now if you see that we saw how strides are how strides can be changed. So strides is just a metadata. It is not the actual data. It is just how to represent data. So there are again two concepts that we'll do that we'll see. So we'll see what views are, okay, and what copies are. Maybe I'll write copies. What are views and what are these copies? Okay. So what is a view basically? A view is just a reference. Taking the first thing, a view. This is a reference. So if I write it, it is just a reference. So it's reference to the original data. So as we saw in the code, you had that array. So you had the original array, okay, and then you had array reshaped, because we took this reshaped array from this array. So this is original. So this array over here is original array. So this is original array, and this was a view. Okay, so what I said about view is now, so view is just the reference to the original data. Okay, when this view is created, no new memory is allocated. So here no new memory is allocated. It's allocated. So you don't get to see a new memory, but what basically it does is it is referring to the original memory. Okay, so why is it necessary? Because the first thing is it will give you, so if I just write it for the sake of completion, it will give you shared memory. So you are sharing memory. Okay, then the second thing is because of now the data is allocated, so creating views is basically faster, because you're just giving references. So you're just giving references, you don't need to copy paste. Otherwise, if you have to produce the copy, you'll have to copy all the elements to new, and you'll have to access the memory and then write it, then again access, again write it element wise. So it gives you faster, maybe what I call efficiency. So I'll say a faster access or efficiency. Okay, and then one more thing is mutability. So what is this mutability? So mutability is sometimes good, because if you change something on original data, these changes will also appear in these views. Okay, so example in the views, I showed you one example when you use this reshape. Okay, and we'll also see slicing, and there we'll also see these are also views. Okay, so when are these views useful? So why should you care about these views? So these views, when you want access or modify a subset of data without copying it. Let's suppose you have data, you want just subset, because instead of copying, now you want faster access, so it is better to just use the view. Okay, so in common libraries, even NumPy uses it, pandas uses it, and maybe other libraries also. Okay, what they do is they'll just use the view rather than these copies. Okay, so this is the concept of views, and we'll now I showed you one example where it was shown that own data was false. That means it's a view. Okay, and the other thing that I want to discuss is copy. Okay, so copy basically is independent duplication. So it is independent duplication. So you are doing all the things here. So when a copy is created, a new block of memory is getting allocated. So you are taking this data and allocating a new block of memory. Then the original data remains unchanged. Okay, when copy is allocated. Okay, so if you change the data in original data, that won't reflect in that copy. Okay, so what are the characteristics? So characteristics are, so there is a separate memory. Separate memory. So as in views, they had shared memory, and now there is independence. Okay, independence. So by independence, I mean there is not mutability. So if you mutate one data, it won't reflect in other data. So here, changes made to the copy or changes made to the original data does not affect. So they don't affect each other. Okay. And then, but the problem here it has memory overhead. So I'll write it with red. That means it's a problem. It has memory overhead, because you are now allocating different memory to it. Okay. Now in the copy, what we have is we have deep copy versus shallow copy. Okay. I'll also come to that. So deep copy. We have deep copy and shallow copy. I'll tell you what the difference between. Now we have, the first thing is we have view. Then we have copies. In copies we have deep copy and shallow copy. Now first I'll just show you some examples of views and copies. Then I'll come to this deep copy and shallow copy. I'm going back to the code window. These concepts again are generic concepts. Okay, these concepts are not relying on only NumPy. So they are generic concepts. NumPy is one of my means to show you these concepts. Okay, these concepts do apply to, in general, Python, in general any other language, and in other for other libraries. So here we are teaching you art of programming rather than just NumPy or maybe Python. Okay, I'll just create new file here. So code test10.py. So I should not create now. I should create test1.py like this with underscore. Okay, can somebody tell me why did I do it? Why I did not do it like this, test1.py or test10.py? Can somebody tell me? Because I'll tell you the reasoning why I did it. Okay, because I want you to learn everything that I do. I did it because, let's suppose if I created test10.py. Okay, now I know that there is a file test1.py. So Linux supports auto completion. So if I just run this test1.py, okay, so if there was 1 and 10, so it won't auto complete. Okay, it will tell me, okay, there are two copies, 1 and 10. So I'll have to manually type. So now if I wrote _1, okay, now this I made it separate. So if I just press underscore and then press tab, and it will auto complete the files now. Okay, now I'm just writing this test1.py. Now I wanted to show you the first I'll show you the view. I think I showed you one of the views, and maybe I'll show you another example of by using the slicing, because we are going to discuss slicing the next topic. So what I'll do is import NumPy as NP. This is the first thing, and then what I'll do is I'll create an array. So let's call it ARR. This is the array. I'll say np dot a range. Okay, a range, and then I'll say give me 10 elements. Now if I print this, so you know that 0 to 9 will get printed on the screen. So I need to say Python test 1.py. So if you see 0 1 2 3 4 5 6 7 8 9. So now if I want to slice, so what is a slice? So array, maybe I'll say SL. Okay, that's equal to array, say I want to slice from element 2 to 4. Let's suppose I want some 2 elements. So if I now print this slice, print this array slice. Okay, so if I now run this, so you can see this 2 and 3 got, this is basically this. So I said if I made any change in the ordinal letter, that change will, I can also print, sorry. So what I can do is I can also print, is it in the same? So I'll have to again say bash okay, I have to activate deep learning because it somehow happened. So what I'm saying is, so if I now print those flags for both of these arrays, so I'll print flags and I'll see which has own data and which does not have own data. Array dot flags. Okay, and then I'll print array slice dot flags. So print array slice SL dot flags. Okay, so now if I print it, you can see, oops. So I have to basically print Python. Let's create it a little bit bigger so that it's visible. Python test 1.py. So here if you see this, the first thing is array flag. So this is, if you see it, it is own data is true. That means it's original thing. Okay, if you see own data, it's false. That means it's a view. Okay. Now if I make any change in this slice, let's suppose I'll say I'll make any change in the slice. So if I print this afterwards, so I'll print this over here. So let's suppose I made change in the slice array SL of 0 is equal some negative 20. So that should be, so if you see it, so negative 20 is also here, so it came in both the copies. That means it is just a view. Okay, so reshape also, it creates a view, not a copy. Now if in order to create a copy, because sometimes you will want a copy, so for that what you have to do is you will have to separately import in the module. That is, you'll have to import this copy, or maybe in the NumPy itself there is a copy. So what you can do is, so you will say if I have to make a copy, so let's suppose what I can do is I'll say this dot copy. So let's suppose I'll do this. I'll say array dot copy. Okay, copy is a method that's defined in Python, that's defined in NumPy itself. So now if I do the same things, okay, initially I will do this. So now this thing gets created. If you see now, this own data is true for both of these. Own data. This is true for both of these. I just added a method copy. So copy is the inbuilt method in NumPy. So if you see this, so here you can see that now this copy explicitly told this is copy. So if I change something in this slice now, so that means this change should not appear in the original array. Okay, now if you see, this is the original array 0 1 2 3, because I changed something in the slice, that this array, when I copied it, I changed this element, so it did not reflect over here. Okay, is the concept of copies, NumPy copies and the NumPy views clear? Can I consider that it's clear? Okay, now we'll see what's the difference between a shallow copy and a deep copy. Okay, so going back to, maybe code is better to show it, but first I would like to explain you a bit of theory and then we'll go back to the code. Okay, so now we have shallow copy and versus deep copy. So first we'll go to shallow copy, deep copy will be the counterpart. So a shallow copy, when it's created, okay, so a new object is created, but it does not create copies of the objects that original data refers to. I'll tell you what that means. Okay, let's suppose we have original data. The original data is like this: 1 2 3, and then we have 4 5 6. So what I said is, I said when a shallow copy gets created, okay, it creates a new object, but it does not create the reference of the original, but whatever original object refers to, it does not create the reference for these copies. So let's suppose if you see this 2D matrix, okay, now you see that this is a nested, maybe a list, okay, there's a list, nested list, Okay, nested list, let list within the list. Okay, now what I can do is, if I want to do a shallow copy, if I just said copy dot copy of this original, what will happen is, so it will create a new it will create a new copy. Let's call this a list, maybe original O, and I'll create a shallow copy. So shallow copy will again, so it will create a list. Okay, so it will create a new list, but this is a reference. So internally this is object reference, so this is referring to it. So internal object, if you see, it is keeping them preserved. That's what I said, that the objects in the original object refers to, so they are not changed. So original object is this, it referred to these objects because within that there is an object. Okay, so first initially we had this nested list, so within that we had a list inside. So nested list is an object, a list within a list is also an object, so this list separately is an object. Okay, so what it does is, it created create a memory representation of the external object, but this object referred internally to some objects. Okay, these things only modified, these will be referred like this. So it created this list, so now there will be a reference to this and there will be a reference to this. Okay, that's what is meaning of shallow copy. It does copy, but how much it copied, it just copied the outer layout, but inner layout, when it was referring to some other thing, so it did not copy that. It is better understood in the code. Okay, so let's go directly to the code and see that. So here if you see, so what I can do is, I can create a new file, code test underscore 2.py. so here this, so what I'll do is, do tell me if you are not able to hear me, because sometimes I hear my voice and I'm thinking that headphone got disconnected. Are you able to hear me?
Yes.
Okay.
Yes.
So what I can do is, I'll create a list. So this is original, I'll create a list, original list, which is a nested list. So I'll say list of lists. This is 1, 2, 3, and this is again and the element 4, 5, 6. Okay, so if you see, whole of this is one object. So within that we defined this is actually one more object. So this is one more object, and here internally this is again 1D array, this is again a referring object. Okay, so if I have to create a shallow copy, so what I'll do is, I'll import a module known as copy in Python. So import a copy. So now what I can do is, I can create a shallow copy. So this is shallow copy. So shallow copy, how do we define it? You can say copy dot copy is a method in that copy, and you say that original. Okay, so if I just print this original thing, okay, and if I print this shallow original, shallow copy basically. So now if I want to run it, Python, so this is test 2.py. So here you can see that these are two copies, but I said this is a shallow copy. So shallow copy basically means, so internally this is referring to this and this original. So that means if I modify internal elements, if I modify inner reference, so that means that copy should also appear in the shallow copy. So let's suppose I'll modify it like this. After shallow copy is created, so I'll modify original of, let's say 0, 1. So basically this element, this 2 I'll modify. So I'll modify it with 18. So now my assumption is that this is a shallow copy. Shallow copy means the original was kept similar, but internally it was referring to this and this. Okay, and these things have not been, these are just been referred, because these and the memory has not been allocated for that. That means this 18 should appear in both of these things. So if you now see, the 18 is in both, but still I applied copy. That means, so that's why I said a shallow copy, when it's created, a new object does get created. Okay, but it does not create the copies for these objects which are referred by the original object. Is the statement clear now? For how many students is the statement clear? So it does create a new, let's suppose a list, but internally this list was a nested list. So internally it already had objects, and when a shallow copy is created, so what we basically do is, we do not internally create new new memory and do not allocate new memory for these internal objects. So we just refer to them. That's why it's called shallow copy. Okay, so instead of this, we should have deep copy. Deep copy basically means within a list, if there is nested list, there are references. These are also modified. So for that, what we do is, we just say deep copy over here. So we'll say it is a deep copy. That's why shallow means surface level. Okay, sir, at surface level we are creating it, but deep means change everything. Okay, do not just create. And again, why is it done in this manner? Because we when we perform these operations, when we implement these operations, we want a faster access, we want efficiency in that for the user. Okay, so you have to explicitly say deep copy. So if you now create deep copy in here, so now you can see the 18 also got only got changed into original. Okay, and this basically is a deep copy now. So this did not get changed into deep copy. So how many of you are clear with the shallow copy and deep copy now? Is it clear for everyone? What is a deep copy? What is a shallow copy? So shallow copy basically means surface level copying. But internally, if that references to some other object, these things are not copied. Okay, references are not copied. Not references, whatever it refers to, these objects are not copied. That only references are kept. But deep copy means that you are copying everything. You are copying from start to the end. Yes, yes. Okay, I don't think there is a question. So should we take a break over here for maybe a couple of minutes? So I hope that now the concept of views, okay, and then copy. In copy we saw about a deep copy and a shallow copy. This is somewhat clear. Okay, so if these things are clear now, so we can move ahead. So I'll just turn this off. So these are the two things we saw: what views are, what copies are, what deep copies, what a shallow copy is. I heard some sound. Is there a question? If there is a question, I can take that. Okay, that is not a question. So now what we'll do is we'll go to the topic of, because we saw flags, we saw these strides, and then we saw these views and copies. Now we are in a good position to understand the indexing and slicing. Okay, now have this topic of indexing and slicing. Okay, so indexing and slice, we will index and we'll slice. Okay, and then we'll also see how does this stride and what happens to these things, and where is a copy created, where is basically this what I can say, where is this view created. Okay, so we'll see indexing. So in indexing, what we'll see is, the first thing is we'll see basic indexing. So why have we named it like this? I'll tell you why. We'll see what a basic indexing is, that we'll see what is an advanced indexing. Advanced indexing. Okay, now in Python, normally I think we had this indexing topic. This topic also we are covered in lists. So if you see how we have indexed it, let's suppose this is a NumPy array. Okay, so we start indexing like this. So this is at index 0, at index 1, at index 2, at index 3, 4, 5, 6, and let's suppose these are the only elements that are there. Okay, so from here it will be negative indexing will be -1, -2, -3, -4, -5, -6, and -7. This is the negative indexing. Okay, so in Python what we have is, you will just have this. So if let's suppose this is x, so I'll say x of 0. So x of 0 means basically this. Okay, x of this something, let's suppose x of 3. Oh, I did something like this is 1, 2, 3, 4, whatever. I think I made a mistake somewhere. 0, 1, 2, 3, 4, 5, and 6. Okay, so x of 0 is this, x of 3 is this. Okay, x of 6 is this. So this means x of, that means go towards that. So this is called as positive indexing, and this is the negative indexing over here. Okay, now let me show it in the code for the sake of completion. I hope that everybody will be comfortable with this, because we have done it with lists. Okay, let's create a new file over here. So we'll say code. So this is test of 3.py. Okay, so here is the file. Now what I'll do is, I'll create an array, call it x. Maybe first I'll import NumPy. Oops. Import NumPy as np. This is the alias. np is the alias, the same name. So now I'll create an array x that's equal to np.arange. np.arange, and I want to create some 10 elements. Okay, so if I print this, so what should be in the array? That is, oops. So there should be in 0 to 9. If I print this, this is what it is. So Python, oops. So this is Python test underscore 3.py. So this is 0, 1, 2, 3 till 9. This is my this. So the first indexing I'm saying is, by indexing I mean that I should get access of the individual elements. So that's why it's called indexing. Okay, because each of the elements is indexed. Now we saw two indexing. The first is positive indexing. Okay, the second is negative indexing. Negative indexing is from the right, and positive indexing is from the left. So if I want to access, let's suppose this element. Okay, let's 3. So I should say print of x of 3, something like this. So it will give me a scalar. Now you see this is a 3. Okay, in the reverse, if I say let's suppose -1, this is -2, this is -3. If I say -3, I should get 7. -3, if I just get it. So here you can see this is 7. So this is the simplest indexing. Okay, because we are now under the heading basic indexing. Basic indexing. So in basic indexing, what we saw is, we saw that in normal Python that we have x, and then we have this expression 1, 2, 3, and then it's equivalent to if you basically do this. So this is the normal indexing. Then in this we saw what is the meaning of positive indexing? That means go from left to right. Okay, from 0 to, let's say if index is I, okay, till I. So this is 0 to I, so the total will be I plus 1 elements will be there. So negative indexing starts from -1, okay, till the elements that we have there, -1 to -2 -3. If you have 7 elements, it will be till -7. Okay, so this is one type of indexing. So if you directly want to element. Now what you can do is you can also slice these things. Okay, when you index it, okay, so when you index it, it is just referring to that element. Okay, it is again creating a view. Okay, if I just printed this x of 3, because this again is an array, I'll create dot flags. Okay, I hope that this should be, but this is skill anyway. This is a skill. I'll see this is skill. This method is not applied on this. Okay, this is not a. Okay, but its own data is true. What am I printing? Am I saving it? Is the same thing that I was going to print? Python, because we have to see that is the program name correct also. Python test. This is 3, I think. Yes, 3.py. So now if you see its own data is true, that means if you create this index, so if you create this index of 3, this again is a NumPy array. So I can print the type also first. So I can print the type of x of 3. So I'll see if it is a NumPy array. It should be. Okay, it is showing NumPy int 64. Okay, this is not actually an array, this is not an ND array, this is just one element. Okay, so this creates a copy. If you do this index, this creates a copy, but this copy is only why? Because it is not referring to the whole array or a part of array. So this is just indexing. But if we slice, what is the meaning of slicing? Let me come to the slicing. Okay, what is slicing? Okay, coming back to slicing. Okay, I'll turn off this VS Code. So what is slicing is, so now if you have an array like this, we had array 0, 1, 2, 3, 4, 5, 6, 7, 8, maybe 9 also. I think I should see it. Yeah, I think 9 also. We had 9 because we created 10 elements. So slicing basically is if I want to slice from this. By slice I mean, let's suppose I want portion from this to this. So this part I want. So I want to slice out of this. That's why it's called slicing. So slicing basically means you just want a part of this ND array. So maybe slice, I want one slice can be this, or maybe you want, let's suppose this slice, or you want different portions of slice. You want this, and you want this. Okay, you want maybe these 3 elements. It's also slicing. Okay, so how do we slice? So in this 1D array, how do we slice is, if you have this array, so you have this array, so we'll slice it like this. So we'll say where to start, okay, and where to stop. I'll say s dash, and what is the step size, s double dash. Okay, we'll have start, then we'll have stop at a certain position, and then we'll say how many steps to jump. We saw this in range function, we saw this in a range function. We're again seeing it in slicing. So in slicing, what I said is, so you'll start from somewhere, you'll stop at something, and you will have this step size. Okay, let's see that in the window, and then we'll get a clarity. So if you see this, so how can I slice? If I want, let's say I'll print this x, only x I'll print first, because this is the array that we have that will slice. Let's suppose I want slice from this element 3, 4, 5, 6 till 7. So what I can do is I'll write slice. So slice from x till, so I want it from the third element. So I'll say third by a third index till, let's suppose, the 7th index. I want 7th index included, so I should write 8, and then I should write steps as a 1. Just go one by one. Okay, so this is a slice. So now if I print this slice, so now if you see this slice got printed 3, 4, 5, 6, 7. So initially we had 0, 1, 2, 3, 4, 5, 6, 7. So we have 3, 4, 5, 6, 7 now. So what this slice basically, it is just a view, it's not a copy. Okay, if I just show you, so what I can do is I can say print slice of dot flags, because we have a flag there, that's his own data. So if you now see over here, own data is false, that is, it is not own data. Okay, you can see this is that print x, this thing got printed. Okay, 0 to 9, and then we have a slice. Okay, and this is what, and we can change the step size also. So if we want to change the step size, so let's suppose I only want to print the elements which are at even indexes. So I'll say 0. If I do not write anything, that means take up till the end, take everything. And then if I write, take 2 steps at a time. So what it'll do, it'll take first 0, it'll take 2, it'll take another jump of 2, it'll take 4, something like this. So if I just comment this, the first thing is you understood that this is a view. Now the second step is, you said, what I said is, I said that if you just want to jump 2 steps, so it started from 0, jump to this 2, jump to this 4, then jump to this 6, jump towards 8, and then there was 9, there was nothing to jump. Okay, what if I do from the 1? Then it will take only the things that are at odd indexes. Okay, you can see this. Okay, but keep in mind that all these things are views, they are not copies. That means if I make change anything either in original or in the slice, the changes get reflected in both of these things together, because they are just referring towards each other. Okay, so this is how you use the slice. Okay, and now the important aspect is how can you slice multi-dimensional arrays. That is very important, and sometimes it takes a lot of efforts to think about that. If we have a multi-dimensional array, okay, let me create a multi-dimensional array. So let's create np.range of, maybe I'll create this array. So this is the array. So if you see, if you print this x, now your session 1 will come into play. So if you see this, so this is 0, 1, 2, 3, 4, 5, 6, and its dimensions are 2 by 3. It's of shape 2 by 3. So how could I have also done it? So I could have just arranged and then I could have reshaped it. Okay. So now what if I say? So the most important aspect is now how to think about these. I gave you a picture. I said, okay, this is like this. So internally, this is 0, 1, 2, 3, and 4. Okay. So this is that. This is that thing. This one. Okay. This is the second row. Okay. That day I told you one way of thinking. Consider this as an array. Now if this whole is an array, if this whole thing is an array, so this is the 0th element. Okay. So this over here is the 0th element. So this is the first element. Within the 0th element, so this is within the 0, this is 0, 1, 2, 3, 4. This is 0, 1, 2, 3, 4. How we can index it? Accordingly. So I told you can think it like a matrix also, like this. Okay, I'll make it matrix here. So now you see each of this is an element. Okay, this is 0 element, first element, second, third, and each of this element itself is an array. So you can think it like this: 0, 1, 2, 3. So if you have to, let's suppose, get to this element, so that means go to the first row and the first element. Okay, x1, 1. So let's suppose we'll go back to coding window and show it there. So if I have to print, I'll print x1 of 1. If I print it, there will be a scalar value, that is 6. So I'm going to this, and I'm going to, this is 6. So over here this is 6. So this is how you should think in this. So you can also write it like this. You can just put a comma over here. These are equivalent in NumPy. So if you just put it like this, again the value is similar, 6, 6. Is it clear? Is it clear? For how many people is it clear? So I am saying pick up the first row. So this one basically tells me go to this first element. So it is going to the first element. So how to prove this? If I just say x1, so x1 basically should give me whole of this row. Okay, whole of this row. So if I now do this, so you can see it gave me whole of this row. And now when I put this comma, that means go internal to this row. Okay, so it is like this. So I'll give you a picture to think about it. So because this is very important to think, so I'll give you a picture like this. So let's suppose you have these two things. So you had an array which itself is an array. That array is of 2 elements. Okay, this is the first element, this is the second element, and each element itself is an array. Okay, each element itself is an array, and within that each thing is an integer, something like this. So I am saying this is my array. So this is the 0th element, this is first, this is and the picture to look at it, not just in the matrix format. So internally this is the 0 index, 1, 2, 3, 4, 0, 1, 2, 3, maybe 4 also. So what I am saying is if I just print array of 0, so it is at this position, it is at the outside shell, okay, at the first thing. So it is saying, okay, array of 0 basically means I need to print the whole array. So this is whole of these things, this is whole of that thing. Okay, now if I need to go to internal element of this, I need to put in the index. So I am saying array of 0, that means you are in this. Okay, within this if I have to put something, I can go anywhere, I can go to this 4. So I'll write 4, so this will give me this element. Okay, if I want to go to this, I'll say array of 1, that means I'll go to this array, that is the 1 array, and I'll say give me second element, I'll give array 1 comma 2. For how many of the you is this clear? Is it clear? Can I assume it's clear for you? Okay, now we'll see some advanced things, because now I'll change the dimensions again. Okay, now what if I want to do like this? See, if you have this picture clear in your head, now the question is, I'll just change the format of this. So I can write it like this. Oops. So I can write it like this, so that it looks like a matrix. So what if I want only this? I want 1, 2 and 6, 7. Okay, I want 1, 2 and 6, 7. That means I am selecting all the rows. Okay, I want all the rows to get selected, but in the column what I should do is I should only get the first and the second column. Okay, I'll again make a picture of this. So okay, because that's the way to think it. That's why it's sometimes confusing. So if you see this, so this is my 0th element, okay, and this is my 0th row and first row. So what I want is I want to select all the rows, but among the rows I want to select only these columns, these two. That is, this is 0, 1, 2, 3, 4. Again the slicing concept will come because I am somehow slicing this thing. The question that is, I want this 1, 2, 6, 7. This is what I want. Okay, out of this. So now, if you have this map in the memory, so what you should do is, so you know that this takes me to the rows because I have to select all the rows. What I can say is select everything in the rows. I'll just put this colon. Okay, select everything in the rows. Okay. Then what I'm saying is, I'm saying within this, but just check this because in the second axis, this is my axis 0 and axis 1. So I hope that you know this. So this is my axis 0, and this is my axis 1. If you understood this, you are understanding the whole indexing part altogether, and you will have never problems by reshaping this, because I'll tell you what is a real example. I'll tell you one of my case studies that I did, and it was the headache to just split it. So this is axis 0 and this is axis 1. So now I want 1, 2, 6 and 7. So I am saying that in axis 0 do nothing because I want all the rows, but in axis 2 I want only specific rows. So if you see this, I am putting this comma takes me internal. So I am saying now only select the first, second till third. Okay, I'm saying 1 is to this and nothing. So if I now print this, so hopefully what should get printed? 1, 2, 6, 7. Say if I print this, so I'll print python test 3.py. You can see that printed 1, 2, 6, 7. So how many of you is it clear now? And now you saw that it again is a 2-dimensional array. Is it clear? Is it clear? How many of you can say that I understood this? Now one important aspect over here is
Please again. So can you explain this again?
Yes, sure, no problem. So what I'm saying is, with the picture that you have to see, the picture that you should have in the head is this. So we have an array. Internally we have an array inside that. Okay, and then if you see this array basically contains two elements. So array element 0, element 1. But element itself is an array. Okay, that's why it's called a multi-dimensional array. This over here is 2D array. So this is an array element 0, array element 1. Okay, so in this what I'm saying is, so now if you just say array of 0 will give you access to this element. That is the whole array itself. If you want an internal element of then what you do is you will just add comma, and then you say, let's say I want to get second element, you will get 0, 2. Okay, this is how you access these elements. Now what I said is, if you see this example, I said here we have, this is axis 0, that is row wise, and these are the columns, that is axis 1. Okay, now I said I want all the rows, and I just wanted this 1, 2, 6 and 7. I said what I want is, I want the data from all the rows, but I want only specific columns. So for that what I did is, I said, okay, my thing is like this x, this takes the rows and it takes the columns. If I just put comma inside, I want all the rows means you should add nothing, just add the columns. But initially we saw if you just put x, if you just wrote something like this, x of something, so it prints everything in the x. That's what, before this comma I added this colon. So I said basically select all the rows, whatever rows you have, but now be specific about the columns. So this is axis 0, so along axis 0 select everything. Now in the axis 1 only select this and this column. That is, if you see this, so this is 0th column, first column, second column, third column and fourth column. Only select columns 1, columns 2. So how to do that? Because now in this we have 3 columns here again. So 3 columns are start, stop and the step size. Okay, I'm saying start at 1. Okay, start at 1, and then go till 2 because it will take 1, go till 3 because it will take 1 and 2, and step size is 1. Okay, if I don't even include this, it will by default take 1. So if I write it like this, nothing, comma 1, 3, 1. So I'll again show it on the code. So here if you see it, so I'll take nothing. So I can write it also like this. So I can take 3 columns because this means start. Okay, this is stop, and this is the step size. Okay, this is start. Which row should you start from, and then why should you stop in the rows, and what is the step size? So this is along the axis 0 before this comma. If you see, this is before this comma. Okay, so what I'm doing is I'm just putting them. I'm saying nothing, nothing and nothing. That means select everything. I'm putting 2 columns. If I put only 1 column, doesn't make a difference. Okay, so now what I'm saying is select from the first. Here again it is start, then stop, then the step size. So I'm saying select the first column and the second, stop at 3. So I should ideally add 1, but by default it's 1. So I'll select 1, 2, 6 and 7. Okay, this is 1, 2, 6 and 7. Okay, now tell me how can I select this 0, 5? If I select this 0, 5 and I want to select 2, 7 and 4, 9. Can you tell me how to do that? This is a question to you. Now what I want as an output is 0, 5. I want output like this. So 0, 5. Okay, and then after that, rather I should say this 0, 2 and 4 in the first 0, 0, 2, 4. And then in the second row, what I want is, oops, in the second row, I want 5, 7 and 9. 5, 7 and 9. Okay, tell me what should I write? Yes, go ahead.
Colon, comma,
Colon, comma.
hmm,
Okay.
colon, comma. After that we will write what we will write. We will write colon.
Colon, okay.
We have to select everything.
Mm-hmm.
And then what can I say? We want a stride, or we want a steps of 2. So in the end, in place of 1, we will have 2. But
We'll
what
have
about 3?
2.
Yes, but
Until, because we're selecting everything, and just take 2 steps. And
yes,
and start from 0. That means start from the start.
yes,
And now hopefully we should get this. Okay, now if we run it, so now you saw 0, 2, 4, 5, 7, 9. Is it clear now? For how many people is it clear? Because this is very important concept, very crucial. Because now I'll again add more x's. This was just axis 0 and axis 1. I'll add more x's. I'll keep on adding more x's. So for how many of you is it clear? Muzaffar, is it clear? This is a very important concept, and I have seen people getting confused. Even I have seen people who have coded for couple of years, they get confused when you reshape them, when you should, okay, what is the result of this? They still have to look, okay, what is the dimension of this? What's the dimension? Okay, they have to make these maps, because the first problem is they probably may learnt it wrong, and that it gets stuck with them. Okay, and you also might, if you are coding, and you also might have felt this, this sometimes is very tricky, okay, to do this. Now what I'll do is, I'll make it a bit complicated. Okay, not that much complicated, I'll make it a bit complicated. So what I'll do is, I'll go back to the coding window, I'll ask you people questions. So now what I'll do is, I'll use the function arange. X is equal to np dot arange. Okay, so what I'll do is, I'll create 2 multiplied by 3 multiplied by 4 and dot reshape. Okay, and then I'll say 2 comma 3 comma 4. Okay, what should be printed if I print x? It's a 3-dimensional array. Okay, now let me show you how to think about 3-dimensional arrays. Okay, this is a 3-dimensional array. Oops. So if you see this array, this over here is 3-dimensional array on the right hand side. If I show you like this, oh, so what I'm showing is it's here. So if you see this over here, this is the 0th element, this is the first element. Okay, so this, I think again it like this. So you have a bigger array, you basically have an array. Okay, that array has element 0 and element 1. So within that array there is one more array. Okay, like this. Okay, and within this array again there is another arrays. So there are again elements. So here we have 4 elements. So here if you see this, within that you have 3, rather 3, because it's shape of 3. So 0, this is something, I should make it like this, a little bit maybe bigger like this. This is a picture that you should have in your head. Okay, this is the array, original array, because it's a 3-dimensional array now. Now the 3-dimensional array looks like this. So if you see, within the array there is array, but each array element again is like this. Each array element is like this. So each element of the array itself is an array. Okay, there is an array of 3 elements. There is an array of 3 elements. There is an array of 3 elements. Array of 3 elements. Okay, this is one way of looking at it. This is one of the ways to look at it. You have an outer array, so this is that 0, this is that 1. Again you have this 0, this is the 1. Okay, now what you have internally, this is 0, 1, 2, 0, 1, 2, 0, 1, 2, maybe it's 4 also. It's 4. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and something like this. Okay, this is how you should think it as a map. Now if I want to access one element, so if this picture is clear, you can take a screenshot of this picture also. So this is the picture, this is the outer array, it starts with 0, 1, and internally there is an array, so that is 0 and 1, and internally again there are these. That's why it's called 2 cross 3. Why is it 2 cross 3? Because this has 2 elements, and this is 2 cross 3 cross 4. This is 2 cross, and then each of this has 3, rather it has 3 elements, it has one more. Internally it has, this is 2 elements, and then this has 3 elements, and it has 4 elements. That is 2 cross 3 cross 4. Okay, 2 is the outermost, And then when you go a bit inside, it is there are 3 elements, and when you go inside the element, there are 4 elements. That's why it's called 2 cross 3 cross 4. Okay, this is one of the ways to look at it. The second way is you had like this. You had 2 cross 3 cross 4. So 2 basically means how many you had these 3. You should internal the first thing is 2 cross 3 cross 4 means this. This is 2 elements. Okay, internally there are 3 elements. Each has 3 elements. Internally each has 4 elements. That is 2 cross 3 cross 4. If you make a matrix 3D matrix like this, so how should you think? So you should think from the other way around. So we first saw 2 cross 3 cross 4. We should now see 3 cross 4. So that means 3 cross 4 is this. So 3 rows and 4 columns. You should start from the column. This is columns and this is rows. Now these many are my rows, 3 rows and 4 columns. Okay, and then I have 2 slices. 2 slices is like this. I am putting back to back 2 slices. I have first slice like this, and second this is 3 cross 4, and the slice is the same slice like this. Okay, and then I am putting them back to back. I am putting it along this dimension. That means backwards. Okay, now if you see this, there is axis 1, axis 2 and axis 3. So if you see this along here, if you see this is axis 0 now. So this along here is axis 0. Okay, now the rows, this is axis 1 and this over here is axis 2. Okay, so in here this 0 and 1, this is my axis 0. Okay, this is my axis 1. These pinkish blocks are my axis 1. And internally this is my axis 3. So axis 0 if you see in here, so we have this and this is axis 0 and this is axis 1 and this is axis 2. So for how many of you is this picture clear? For how many of you can I assume that you have this picture clear? Okay, now if I have to, let's suppose, get one element out of this. Going back to the coding window, if you see that code is still there. So what I have, so this is my code. So I have 0, 1, 2, 3. If you see this, so this is just back to back 2 slices. These are 2 slices. The first slice, the second slice. So if I just print this x dot shape, let's suppose. If I print x dot shape, so you see this 2, 3, 4. So what is 2 basically? 2 means they have 2 slices. So this is one slice and this is the second slice. That's what 2 means. What is the meaning of this 3? 3 means each slice has 3 rows. 1, 2 and 3 rows. Each slice has 3 rows. And for each row there are 4 elements. This is 4 elements. That's what I said. So this is axis 0, okay, and this is axis 1 and this is axis 2. Now I hope this is clear. So how we can, let's suppose if we want to take this element, let's suppose 6. Can somebody tell me how to now take the 6th element? So what I can do is I can say x of, so the first thing is I should go to the first, that's 0th element. Okay, I should go to the 0th element, and then what I should do is now from the 0th element, now the second thing is in that I should go to the first row. Okay, in that I should take the second element. Okay, and then if I print this, I should hopefully get 6. Okay, that's what the 6 is. Again showing you this is the 6. So first showing you x, let me print that x also. Oops, I printed capitalize X. Oh, so now if you see it, so this is 0, 1, 2. So I got the first 0th element. That is 0th element is whole of this. So how to prove that? So if I just go towards this, if I go to just 0th element, so what it should do is it should give me this 2D array. Okay, this is the 2D array. This is the 2D array. So if I just write it like this, so I'll print something like this. So if you see, this is my 0th element. So in the 0th element, I want to get the second row. Second row basically means first index row. I'll write 1. Okay, if I want to get the second index element, I should write 2 in here. Or I can write it in the shorthand without these braces. I can just put commas. I can put comma, then I can put and the comma over here. Okay, and then oops. So here if I write it like this, so it should give me the same result. Is it clear? This is called a syntactic sugar. Probably the syntax is different, but it probably does the same work. But if you ask me, this is less efficient. This thing is less efficient, and then that's a homework for you people. Why is it less efficient? What is it doing? Because it has to do additional work. Okay, this is more efficient. So if you see efficiency wise, this is more efficient. This way of writing is more efficient, but it takes a lot of typing. Okay, this is more efficient, but it will give the same results. Okay, but the other thing that we saw is this. This is less efficient but easy to write, but they give the same result. So what is it called? It's called syntactic sugar. So if something does the same thing, but they have 2 different syntaxes. Okay, now comes the good part. So now we'll see how can you do that. Okay, so this is the 3D array. So what I want now is I want you people to give me, let's suppose, this 1 2, okay, and this 13 14, only this much, this 1 2 and 13 14. How can you give me that? This is just a question, how to extract this 1 2 and 13 14 from it. I'll pause the recording and I'll wait for you people. How can you? The answer that Arshan gave is, first you have to select both along axis 0, select both of these elements. So I selected both of these elements. Okay. Now along the axis 1, axis 1 basically means now you are in that two-dimensional arrays. In that two-dimensional arrays, what you should do is you should select the 0th row. You select this. Okay, that's what he did. Select the 0th row. In the columns, what he did is you have to select this 1 2 and 13 14. Okay, that's why he said 1 and 3. And here, to write it more succinctly, more information oriented, this is like this. So this can be like 0 is to 0 is to 0. And this is again 0 is to 0 is to 0. Okay. So this is the better way of writing it, so that you have everything. This start from 0, or not 0, rather to the end. I'm really sorry. This is 1. And this is again 1, step size of 1. 0, go till the end. 0, go till the end. Okay. And then 1, go till 3 and just have step size 1. Okay. So here if you just erase this, by default this is the value. So by default this is the value, by default this is the value. Okay. So succinct representation is just write one of these, and more succinct representation is something called ellipsis. Okay. If I write that ellipsis, that is put dot dot dot. I don't know how many dimensions you should take care. This is it. Okay, but we have to select 0. That's again one thing. We have to select only 0. Okay, but this will give a different answer though. Okay, here the question was different, so I cannot put dot dot dot. So I'll have to put here select 0. So I'm putting this select only 0 till 1. Okay, and have a step size of 1, and then select all of this. So if I just run this, this is giving me the answer 1 2 13 14. Okay, so this is that 1 2 13 and 14. Is it clear? Is it clear? For how many people is it clear? I'll also show you what you said is you can just put 0 over here, and then you can put this over here, and then just select this one. Okay, 1 2 13 14. So only one difference is when you add these things is when you add this. Let's suppose you added this. I added this, and 0 to 1 is to 1. Okay, then I added 1. There's a difference in the shape, if you see, that you will have to take care. So this shape is the original shape that the original shape has. If I just write dot shape of this, oops. If I write dot shape, you will see the shape is of the original array. So shape is of 2 cross 1 cross 2. Okay, that means it is a 3 dimension, not shape, but basically dimension. The dimensions are similar. So we have 3 dimensions. But if I did it like this, if I did it like this, and then I said select the 0th element, and then I said 1 is to 3 is to 1 is to 3 is like this. So now if I print the shape is this became 2-dimensional matrices. That's the only difference if you just tinker around with these codes, with these columns. I think we have a question. Yes.
So does this slicing have the same order of 1 complexity? The all types of the syntaxes that you showed here.
No.
like
They
this
do something different. That's what I said. I said this is called a syntactic sugar. I think you were here that time. Were you here?
Yes, I was.
So that is the homework for you people. Why is it not performing? Why are they different? This is a genuine question. Even that's a question I asked you people. All these things have because they do probably it looks like they do similar stuff, but syntactic sugar is there, and they have additional steps to do. Okay, that's why the complexity increases. But that complexity is not so huge. Okay, it's a bit because there's no overhead involved. But one important thing that I showed you over here is if you use this. You see the shape. The shape came out to be 2D. If you want to preserve the shape, not the shape actually, sorry, the dimension. How many dimensions are this? So this is a 3-dimensional array. Okay, if I do this, I get a 2-dimensional array. If I print ndim basically says how many dimensions are there. So for this, there are 2 dimensions. If you can see it over here, there are 2 dimensions. But what if I do it like this? Select everything, 0 and till 1, just step size 1, and this. I put it like this. So I am saying now print the dimension. This is 3 dimension. If you want to preserve dimensions, and then you can do it like this. Okay, if you do not want to preserve dimensions, and you can do it like this. And also there should be a question, why does it do it? So why should it do it like this? Okay, that's a question you should answer. You should look for the documentation. So if I just print it like this, so this is dimension 2, what if I just want it to be of dimension 3? I can reshape it. Okay, I can use the reshape. Okay, and then you'll have to look at, because the hard time doing this is when you do deep learning, many other times we're stuck in that. We have to keep track of these batch size. I said you should be comfortable at least till 5-dimensional arrays. 5-dimensional means batch size, and then you have a sequence length, then you have hidden dimensions, how many hidden dimensions you have, then you have also head dimensions. What are the head dimensions? Sometimes you have grouped queries also, so you have to also see what is the group dimension of that. So till 5, 6, if you are comfortable till 3, 4, you will automatically get comfortable till 4 of this. If I just added 5, and I'll just reshape it to 5. Okay, can somebody just tell me the picture? Okay, how will it look like now? So what will happen? So there are 2 pictures I told you. Okay, this is now the 4 dimension. If I just say x dot n dimension, how many dimensions does this have? It has 4 dimensions. This is a 4-dimensional array. Okay, this is 4-dimensional. Okay, how to think about it? Okay, I'll show you one of the thinking. Other thinking I think you should be able to do on your own. So how to think about this? So initially, if we have 1D, we think it like this. If we have 2D, you make a square like this. If you have 3D, you think it like this. Now if you have 4D, so how to think? So you take this block, okay, you repeat it like this. You copy it like this, and then you repeat it along axis 0, along this. Okay, this over here, if you see, this is a 4-dimensional matrix, a 4D matrix. Okay, because if you see, what is the axis 0 now? Now axis 0 is this. This is axis 0. Okay, what is the axis 1? So axis 1 is now each of these things is how many slices are there. So here, let's suppose we have these slices. Okay, now this over here is axis 1. Okay, what is axis 2? So axis 2, if you see, is this over here is axis 2, and this over here is rather this is axis 2, the rows basically axis 2, and this is axis 3. There are 3 axes now. You saw axis 0 is along the whole thing. Then axis 1 is along this dimension, along this 3D, because now you are internal into 3D. So that is this. You have an array like this. Okay, within that you again have an array. Okay, and within that you have an array. Box में से box, something like it. But this is easier way to think. I gave you 2 ways of thinking. So one of this is 4D arrays. So 4D arrays, axis 0 is along this axis 0. So you have, this is the first, this is 0th element, this is the first element over here. Okay, if you are now in the 0th element, okay, now in that you have, this is my axis 1 along this dimension. I should use different color. This is axis 1, this is axis 2, and this is axis 3. Okay, same for here. So this is axis 1, this is axis 2, and this is axis 3. Okay, and this axis 0 is this one. So now 5D arrays. How to think about 5D arrays? So this is my 2D array. Think about like this is 2D array. Okay, this is 3D array. Okay, slicing, putting things back to back. Now this is 4D array. Okay, if we have more, and now this is 5D array. Okay, now having extra dimension. Okay, now you saw within this we have these things. Okay, we are now expanding it through the other axes also. This was our axis 0. Now if you see, this is axis 0. Now this is axis 1. Okay, along this is axis 1. Okay, and now I can see, rather this is axis 0, because we start with rows and then with the columns. So this is axis 0 and this is axis 1. Okay, then where is axis 2? So this is my axis 2. Axis 2, this is my axis 3, this is my axis 4. Is it clear, or is it getting jumbled? Is it clear? For how many people is it clear? If you are comfortable with these arrays, at least till 5D, okay, so then you can slice anything. If I tell you, give me answer to anything, I just gave you even this was a bit complicated for many people. If you ask them, okay, how to slice this, if they don't have this way of thinking, okay, this is how we put it together. Okay, don't have this way, it becomes really hard to do it. Okay, this was just the basic indexing. Okay, I think we are at 6:40. We should take a break and then we'll come back. And then till that, I'll just stop I'll just pause the recording till here and come up with the questions, and then we'll answer the questions. We'll be back at 6:55. Okay. So welcome back, everyone. So till now, what we have seen is we were learning about slicing. So, and we saw about till I think at least till 4 5D arrays, how to slice them and how to think about these things. So here this was a 4D array which we sliced. Okay, now I'll just summarize what we have done is, the first part that we did is we said if we have an array, okay, I'll just summarize. Okay, I'll just copy paste the code and summarize because I have the code written. So that this is the first thing. If I have created an array, this is the array. Let's just run python test3.py. So I'll print this array. Okay, so this is the array that I have. Okay, and then the first thing I said is we can have the indices. So indices will be, so let's suppose if it's a basic selection problem, so we'll say we have positive indices and negative indices. So we can directly use, let's suppose, print, and this will be the result. So x of, let's suppose, 2. So x of 2 is the second element. So if I just print it, okay, so this is x of 2. So let me just, and then what we said is we can also have negative slicing. That is, I can add -2. So this is negative slicing from the backwards. So then we came with the slicing. So slicing, in that slicing we have start value, we have the end value, and we have the step. And in that what we can do is we can say x, let's suppose it starts from 1, go till 3, and the step size is 1. Okay, by default it's also 1. So if I just print this, so this is 1, 2. I'm getting the first element and the second element, and third element is this is basically excluded from that. We have negative indices also. So if I do it like this, so I'll say go from, let's suppose, -3. Okay, I'll say till maybe 4, and by default, so I'll see what it prints, and then you'll have to justify the answer. So it prints nothing because I probably gave the reverse, so I should give -3, -1. Okay, this is the reverse in the 7 and 8. So this is still here, this 7 and 8. So I'm saying go from -3, this is -1, this is -2, this is -1, -2, and -3. Go from -3, okay, then print these two, and basically the by default it is 1. Okay, so if you want reverse also, so what you can do is, if let's suppose you want to print everything in reverse, so you can just write like this. You can write -1 over here. That means go reverse. I suppose it should reverse the list. Oh, see, it reverses the list. If you see, it reverses the whole thing. Okay, 987, because what I am saying, I'm saying select from everything to everything, but reverse this because I added this -1 over here. Okay, that is the negative indices. So you can use the negative indices also. So if we have by default values, if I just do like this, that means it will take everything. Okay, so this is by default. If you don't write anything, this is by default 0, and if you don't write anything over here, this is by default the end, the length, and this is by default 1. If I write 5 over here, that means it will start from 0 till the 4th index, exclude the 5th, and by default 1 value is here. Okay, so this thing is equivalent to, so this is equivalent to x of 0, okay, till 5, and step size is 1. This is equivalent to this. Okay, now these are default values. We also saw this. So we saw the normal thing, normal getting the values, and then we saw negative indices also, and now we can also have like fewer indices also. So you can let's suppose this is a 2D array. If I have a 2D array, let me copy a 2D array. So I'll copy a 2D array like this. So now you know that this is a two-dimensional array. So if I just use the along the first dimension, let's suppose I use slicing like this, x of 1:2. Okay, I'll use this. So what basically now the dimensions are more. So this is a 2D array. So I'm just basically extending the information along one dimension. I'm saying 1:2. Take this. Okay, this is along the rows only. So if you just see the output, so the output is 4, 5, 6 because it is going till 1 and taking the elements like this. Okay, so this is called as when you slice among the first dimension, like the slicing with the fewer dimensions. Okay, it is giving me this 4, 5, 6. But if you take the size of this, you can also see the size or shape rather. So shape. So the shape is 1, 3, 1. Okay, so we have this is actually 3 cross 1, but it's a 3D array. It's a 3D because it took whole of this. Okay, and then added this arrow basically. So it gave me 4, 5, and 6 because that's what I said. 1:2. Okay, and I gave the fewer dimensions. And we also saw other slicing methods. So is there other things? I think we also saw some multiple like this. So we saw something like this print. If this is a multi-dimensional array, so what we can do is x, then say is to comma, because this is a 3D array. Okay, so the first is along x is 0, this is along x is 1, this is along x is 2. Okay, because there are 3 x's. If I just print this, so it should print the whole array. Okay, that's what it did. So now if I want, so if you see this is a 3D array because even if you see it over here, so this is a scalar, this is again a scale, this is again a scale inside, but it now becomes a row. This is a row, this is a row. So this is a row, this is a row, and along together it becomes a matrix. And when you put two matrices together, it becomes 3D. Okay. So now what if I want to select 2 and 5? So how to select 2 and 5? Can somebody tell me how to select 2 and 5? This should be written like this. so that you interpret it in the right direction. The question is that give me 2 and 5. Okay, how to select this 2 and the 5. Any answers? I want to select this 2 and I want to select this 5. So this is x is 0, so this is 0th element and this is first element. So in the first you should select everything. So that's why this is valid over here. So you select everything and then what should I do? Okay, now I'm along the rows and the columns. What rows should I select? I should select only this first row. Has somebody written? Yes, I should select this one and then in the one I should check because there are only one element, so I'll just check it. It should print this. Oops. Just one click, I'll have to write everything again. So now if you see this Python test.3, you can see 2 and 5. So we saw 2 and 5. I hope everybody got the answer. Okay, everybody saw. I think somebody gave the answer also. Who gave the answer? I'll see. I think Fahad also gave the answer. Arshan, you gave the answer, but you just gave it for. You see, it is actually a 3-dimensional array. If you see, it was not just 2D. Okay, maybe this is the first dimension. Let's suppose if you take this. So this is 0, axis 0. Okay, within that these rows are axis 1 and these columns. I can add more elements here. I can add 1, 2, 3. Okay, something like this. But each of this has. Okay, can you tell me the size of this? What is, if I print shape? What should the shape of this? If I print the shape of this array, what is the shape of this array? Any answers? What's the shape? First you should see axis 0, axis 1 and axis 2. What's the shape?
2, 3, 1.
Okay, why is it 2, 3, 1? Because you have because you have two slices of 2D matrices. Then each of the 2D matrices 3 cross 1 matrix. Okay, if I see this, so Python test, you can see 2, 3, 1. Because in the first we have these two. We have a 3D block. Okay, in 3D block we have two slices. Each slice is a matrix which is of 3 cross 1 size. Okay, I hope you got this point. Okay, so now let's move on. Let's move on to this ellipses. Okay, we'll take next is ellipses. So what if you have this array? I'll copy an array. Suppose an array is like this. So this is an array. So it's again a 3D array. So 1, 2, 3, 4, 5, 6 is one slice, and 7, 8, 9, 10, 11, 12 is in the slice. Okay. So what if I want to select elements at index 0 across the last dimension? Okay, across the last dimension only. So last dimension, it has 3 dimensions: axis 1, axis 0, axis 1, and axis 2. So I want to select all the values till the last dimension. So what I can do is, if I just paste this result over here, so I'll probably delete this. So now if I print result, oops. So now what this ellipsis does is, it will by default take all the axes, but this is the last axis. This one is the last axis. So okay. So if I print this, so this is 2, 5, 8, and 11. That is 2, 5, 8, and 11. Okay. This is the last dimension. Last dimension basically means the columns. Okay. And I took the first column. If I said this, give me the third column. The third is not there. Give me the second index column. Okay, and this is the last dimension. These ellipses say skip all the dimensions, give me only the last dimension. If you see here, I'll again go back to the tab window so that I'll show you that in action. So here if you see this, this is 1, 2, 3, and then we have 4, 5, 6. This is one slice of that 3D. Okay, and the slice is like this. This is the next slice that is behind it. So the slice is 7, 8, 9, 10, 11, and 12. Okay, so if you see this, now the dimension 0 is this. So this is dimension 0, or x is 0, x is 0. Okay, this is element 0 and element first. Okay, this is axis 0 and this is axis 1, and this is axis 2, axis 2. So what if I only want the values of axis 2? Axis 2 basically means columns. First I'll take this is 0, this is 1. Then if I want to select a certain column, certain row, I can select a certain row. But what if I want the columns only? I want along the last dimension. What I can do, I can add these dot dot dot. So dot 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 basically means take all the previous dimensions. That's what I showed you here. So if you see it here, I added dot dot dot. This is equivalent to, if I write like this, h is x, okay, and select everything, comma, select everything, comma, then select the first dimension. This is equivalent to this. Okay, so if I just uncomment this, and if I delete, let's suppose this, okay, I hope this is 2, which I wrote there. So if I just see this, if you see, both of these results are similar. Okay, so but what ellipsis does is, because I don't want to type these axes, so I can just type dot dot dot. Okay, these are called ellipses. Okay, just write the name. So these dot dot dot, so over here these things are called as ellipses. Okay, they are called ellipses. So this again, if you see it, it just saves you the time. It saves you, you don't have to, because if you have, let's suppose, 100 dimensional array, okay, and it is possible to create a 100 dimensional array, and you only want to select a specific dimension, what you can do is you can select this dot dot dot. Okay, so here dot 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 means take all, and then when we put the comma and then certain dimension, and you can select it. I hope that this is clear. Is it clear? Then also you can add new axes. Okay, if I just show you like this, so there is a function called as np.newAxis. Okay, keep your focus here. I'll just save this because I haven't created a new file since long, so I'll create test 4.py. Okay, now I want to add new axis. New axis basically means I want to add another dimension. So let's suppose I'm creating an array. I'm creating an array which is a 3D array which we earlier had. So if this is there, so this is let me write import NumPy as np. Okay, so here if I print this, print the size. So what's the size of this? Anybody can you tell me the size? The basically rather the shape, not the size. So what's the shape? Speak it out. Can somebody speak it out?
2, 3, 1.
2, 3, 1. Why? Because we have, it's a 3D array. It is of having 3 dimensions. Then if we have first, these are the 2 elements, and in the axis along axis 0, then we have axis 1 in which we have 3 rows, and then in each of these rows we have 1 element, that is 2, 3, 1. So if I just run it, you can see 2, 3, 1. What if I want to additionally add one more axis? Okay, so what I can do is, there is something called as add new axis. So let's suppose I'll add result 1. So I'll just result. Okay, then I'll say np, maybe x. So first I'll say x, and then because in the first row I have this, and then comma, and I want to add one more axis, so I'll say np dot new axis. Okay, then I'll again type this, comma, type this and this. So now if you see this, I've added this. So maybe I should clear one more, because it already was 3 dimension. I had this column, comma, this, but I added one more new axis. Now if you have this result dot shape, so I'll say print. Let's print the result first. Okay, I'll print the result first. So now you can see this is the result. Okay, 1, 2, 3, but it added one more dimension. If I say, if I added this, okay, have I saved it? Result dot shape. Okay, so over here I think the shape did not get changed. Okay, why is it so? Okay, I need to put one more comma. Yes. Okay, if you see, because I needed one more column, so now I have added one more. If you see at this position, okay, now if I print just the result, so you can see this is how it changed. Now it changed into 4-dimensional array. Okay, 4D, I told you 4D. Consider that block, that 3D block, and it was repeated. Okay, it was repeated twice. This is a 3D block now. It was converted into that, and this was only 1 dimension. Okay, this is 2 cross 1 cross 3 cross 1. Okay, this is what new axis does. And sometimes you on purpose want to do this, and it has many applications to add the axis. Okay, so you can add one more axis by this np.newAxis. Okay, you can add as many axes as you want, and just keep the track of these commas and these colons. Okay. I hope that you can add this axis and you got the concept of these. And there are different data types that NumPy offers. Okay, and you can check the whole list of these. This is what we saw in the basic indexing. Okay, so why I call it basic? Because everything that we created here is just a view. Okay, if I just wrote x.shape was here, so if I wrote x.flags, okay, till now whatever we studied, this was basic indexing, and it created not a copy but a view. If I just wrote flags, okay, what will happen is you can see that here this has own data true, that is this x is actually true data, but the results has false data. So results, if you see, own data is false. So everything that we studied so far, slicing and whatever types of slicing we saw, default values, slicing of different types, so this is called as basic slicing. Why is it called basic slicing? Because it creates views, not the copies. Okay, this is I think there will be more to discuss, but I hope that now you got the basics done. And if you are asked any question on multidimensional, on 3D, 4D, 5D, ND arrays, you should be able to grasp it, because it now you saw how to deal with colons and how to picturize these all the things. Any questions on this basic indexing? Why is it called basic indexing? You have to remember that in basic indexing, I'll just write it. So in indexing we saw basic indexing. Okay, basic indexing because it returns a view. Okay, it does not create a copy. So you can, whatever we saw there, whatever we studied so far in this slicing and whatever methods we saw, so all of these were views. They were not giving us the copies, because now we are going to see what is called as advanced indexing. Advanced indexing or advanced indexing. Okay, advanced indexing, in that whatever the methods or whatever the things that we'll do, they'll basically give us a copy. Okay, they'll not give us the view. So I told you the difference between view and the copy. Any questions still here? Any questions? Now the topic that we are going to take is advanced indexing. Okay, advanced indexing. So what's the difference? The main difference is that when we did this basic indexing, the point was that in basic indexing we got views. Okay, views basically have shared memories, and we talked a lot about that. And this advanced indexing, when you do that, what they do is basically they will give you copies, actual copies. Okay, so the first indexing that we'll see is integer array indexing. Okay, that's called as integer array indexing. What is this integer array indexing? So okay, what will you do is, if you have an array defined, okay, you will have an array defined, and then you will have index of integers. So you will just define integer, then index, and you can just index it. Let me show it. Okay, going back to the coding. Okay, and just creating a new file. So this is code test-5.py. So now what I'll do is I'll import NumPy as np, and then I'll create an array. Array is equal to np.array, maybe a range, and then I'll create 10 numbers. You know what these are? This is from 0 to 9, like, because we have been creating now this. So what I can do is I can create an indexed array, which are integers. I can say index. Okay, this is index is equal to 0, 2, 3. I want these 3 numbers, which are at index 0, at index 2, at index 3. So if I now do like this, I'll say result, and I'll say array of this index. Okay, and now if I print this, if I print a result, oops, I should print Python test5.py. So you can see this. Oh, I'm printing result rather. So you saw this. At this, I should rather multiply it with 2. Okay, let me multiply it with 2. I'll see if it works. Yes. So what I did is I create a range. If you see this, print array. So I created this number. I created a sequence of 2, 0, 2, 4, 6, 8, 12, something like this is an array that I have. And now what I did is I said, give me the elements that are at index 0, at index 2, and at index 3. So the element at index 0 is 0. Element at index 2 is 4. Element at index 3 is 6. Okay, I can say, give me element at index -1. Okay, -1 is basically the reverse one. Okay, so I should be able to get the answer. So if you see this, 18 is at the end. Okay, this is the 18. Okay, so now the main point is that I said they will return you the copies. Okay, if I print a result dot these flags, okay, so their own data should be true. So now I have print this. So if you see own data is true. Okay, that's why it's called advanced indexing. The first thing that we saw is integer indexing. So what you can do is you can just give me some integers, okay, and then I'll just index it with that. I can do it with 2D arrays. Okay, let's create a 2D array. So I'll say np.range and .reshape. Okay, .reshape of 2, 5. So what will this do is this will give me an array. If I print this, this will be of 2 rows, 5 columns, and it will be like this. Okay, I am not worried about this right now. So if you see it over here, so you see 0, 1, 2, 3, 4, 5 is a 2D array. So what I can do is I can say like this. I can say give me rows. I can say row indexes, and then I'll say column indexes, like calls, something like this. This is again the same thing, integer indexing. So if I'm saying select, let's suppose we have 2 rows here. So rather we should have 3, 5, 15. I'll create 15 numbers so that it is easy. So 15 numbers. So I'm saying select, let's suppose 0, comma, 1, comma, second rows. Select these rows, and in the columns select 1, 0, 1. Say 1, comma, 0, comma, 1. So what will happen? What will happen here is, so it will, if I print this, this is my rows and columns. So if I have now this result, I'll just say result of array. So the first thing is I'll write rows, comma, columns. Okay, rows, comma, columns. Now what will happen is it will give me these elements 0, 1. So row no, row 0 and column 1. It will give me that element. So element at row 1 and column 0. Okay, it will give me that. Row 2 and column 1. It will give me that those elements. So if I print this, you can see it. Okay, this was my array initially 3 cross 5. So 0, 1 element, row 0 and first column, row 0 and first column. That is the first element. That's what this is. Okay, row 0, first column, row 1, column 0, row 1, this is the row 1, and column 0, this is the fifth 5, and this is 5, and then row 2 and column 1, row 2 is over here and column 1 is over here. This is 11. So it gave me this 1, 5, 11. This is the output. So again, if I just print the flags, so if I just print it, you can see this is right. Own data is true. That is a copy. Okay, you can do it with multiple things also. You can now also use repeated indexes. Okay, if I do the same thing, if I again create NumPy array dot shape. So the first thing we saw, I'll just write hash. We saw integer indexing, first on 1D array, 1D, that also we saw on 2D array, 2D. Now what we are saying is we can use repeated indices. Okay, repeated indices. Okay, sometimes I said what's the meaning of repetition. If you want to oversample the things, let's suppose this is my range file, and what I want is I can create repeated indices also. What I'll do is I'll just create repeating index like this. I'll say index, I want something like this. I want first element twice, okay, and then I want second element twice, okay, I want -1 element thrice, okay, and then give me this. So this is a result of indices. So I'll just paste it over here. So if I now print this, obvious answer is this. So what I got is whatever was at the first index, I got it twice. You saw this 1 and 1. Then I got 2 and 2. Then I got 14, 14, 14 because I repeated it 3 times. Okay, this is the array that I got. But if you see now, it is a copy. It's not a viv. It's a copy. Okay. So if I just type flags, if you see it over here, own data is true. That means it's a copy. Okay. Is everything clear till here? Any questions? Any questions on index? The first topic in advanced indexing was integer indexing. Okay, how do you use integer indexes? Any questions on this? Okay, just to summarize what we did is, so in advanced indexing, we saw that it gives us copies. That is the most important thing to remember. And then we saw how to use integer indexing, that on 1D, then on 2D also. Okay, rows and columns. Then we also saw repeating indices. If you want to repeat, that's what we saw in advanced indexing. Okay, then we have something called as Boolean indexing. Okay, then we have Boolean indexing. This is again very important. Okay, and people use it every day almost. If people are working on advanced deep learning, they use this Boolean indexing. Okay, but what was the meaning of Boolean indexing? If there is a certain condition, if you have data, let's suppose in data, the example that I described, let's suppose you are dealing with some financial data, and you are saying, okay, give me only those transactions in which the amount spent is greater than 100 rupees. Okay, something like this. And now you have to create a Boolean, what's called as Boolean mask. Okay, so as to filter out those things. Okay, I'll just go to the VS Code and show you the example. Okay, now we have this Boolean indexing. Going back to the code window and to create new file, code test6.py. Okay, now what I'm saying is, I'm saying let's suppose you have transactions like this. Okay, we have import NumPy as NP. Let's suppose you are working with financial data. So your data is something like this. You have a data, I'll call it data. So it is np.array. Okay, and then this array contains some transaction data. Somebody has transacted 100 rupees, 200 rupees, maybe 150 or 140, 130, and maybe 60, 40, maybe 60, something like this, and some other transactions over here. I'll add 35, or maybe here we'll add 25. Okay, what we can do is we can say we can create a threshold. Think it like this. I'll say I'll give you a condition. I'll say condition give me only those things. Okay, where let's suppose the condition is that the value should be greater than 25. I'll say like this. I'll say condition is, I'll write it literally condition. Condition is equal to, so I'll say this data, the data in the whatever in the array that is greater than, let's suppose some value 40. Okay, some value when data is greater than 40. So what will if I print this? Okay, if I print this, it will create a boolean array. So print condition, it will create a boolean array. So I should say Python test 6.py. So if you see, it create a boolean array, true, false. So it is showing for how many elements is true. Now what we can do is I want to filter based on this condition. I want to filter this data. What I can write is I can write data of this condition. Okay, this is called as boolean indexing. Now if you see this, I got 100, 200, 140, 30 and 60. All the others were just dropped off. Okay, and you saw the real implication. So I say if you work, let's suppose, with financial data, so you want only transactions which have a threshold above the certain amount. You want to filter those things, and you are filtering this. Okay, what is base? This base sometimes called as boolean mask. So this over here is something sometimes called as boolean mask, because it's masking the other values. Yes, questions?
How does this internally work? Because the condition is just the boolean array. So is this is there any
It
hidden
overlaps.
data?
So what it does is it overlaps this. There are different ways of implementation. It's very easy to implement also. So what it does is, so let's suppose for the corresponding, if it is true, it will keep that value, and others it will drop. Okay, let's suppose if you see false value, it will drop this value. You see false value or here, it will also drop this value. For the values it sees true. You have also seen that filter. Probably in lambda functions I showed you that those reduce, filter functions, map functions, filter functions. So in that filter, somehow the same thing was being done. So filter was doing the same thing. It was filtering. Okay, if there is true, only consider that those values. So it is doing something like that. So if you have boolean mask, do apply the mask onto this. Okay, whenever this is false, just drop the element. Okay, drop this element, and drop this. Okay, and wherever this is true, keep the elements and make a new array. That's why it's copy. Again, if you see this is a copy. It is not just having a view now, because this is not changing the metadata only. It is changing the whole array itself. That's why it's called advanced index. If I now just drop flag, now if you see it, this should be a copy, because there is no way you can create a view out of this. Okay, if you see this own data is true, that is it's a copy. Okay. Okay, Mahmood.
Could you please explain this aligned flag?
So align flag is basically when we do vectorization, we'll once we work on this. So align basically means without using explicit loops. Okay, and once we'll see broadcasting also, we'll see this align flag also. Align flag basically means you'll align the data in a certain way. Let's suppose I'm saying you have to perform this operation. I actually showed you this in the first class itself. 1, 2, 3, and then you have to add, let's suppose, 4. So what will happen is either you have to run the loop, or what you can do, if you align data somehow, if you align these strides somehow, and you can do broadcasting like this. Okay, you can copy this data somehow into this, and now you don't need to run the loop. You can just add it direct element wise. You align this and direct add in a certain way, so that CPU memory access is faster. Okay, and probably this will get more clear once we learn the broadcasting. Okay, but here you can see that we align the values in a certain way so that we don't use explicit loops. So this is called as vectorization. Okay, that is why this NumPy is fast, because there are two properties. One is called as vectorization, other is called as broadcasting. Because of these two things, we somehow try to just avoid these writing of explicit loops, because we have pre-compiled C code. If we align them somehow, we can directly perform these operations without having the usage of loops. That's why this align is saying it's true. Like it is aligned in a way we can use the vectorization and broadcasting. Okay. So now going again, so we have this boolean, and same thing can be done with the 2D arrays. If you have a 2D array, you can have this B condition. Let's suppose if I write a 2D condition like this, maybe I can reshape this dot reshape. So how many elements are there? I don't know. So can somebody count the elements? 3, 3, 6, 8. So I can say 2, 4. I reshaped it, and I can say the same condition. This is for the 2D arrays. Same thing is here. Okay, I got these elements 100, 10, and even I can reshape them also if I want in a certain way. Okay, so this is what is called as a boolean. Now we can have complex conditions also. So okay, so here we had a simple condition. If you want elements between something, let's suppose you want all the elements between let's say where the data is greater than 40 and less than 100, let's suppose. Okay, maybe greater than 20 and less than 100, something like this. Greater than 20 and less than 100. What you can do is you can say like this: condition is data is greater than 20, and then you can put a little ampersand sign and then you can say data is, let's suppose, less than 100. Okay, now again it will create a condition. Okay, it will again create a boolean mask. Okay, once that mask is created, so I should not, let's not reshape it, let's do it for only 1D, because it will again work same for the 2D. Now if you do this, something is wrong, so I think I should put maybe something like this. Okay, in the precedence order. Now if I work it, you can see that 25, 35, 40 and 60, these are the elements which are between 20 and 100, and this 20 if you see is exclusive, and this 100 is also exclusive, because I'm not writing less than or equal to. If I write equal to also, then I'll make them inclusive. These are complex conditions. No matter how you take, you just have a condition, and then you can basically, there is something wrong with it. What is the condition is this? Less than equal to should be here. Okay, because I'm still thinking in the mathematical notations. That's a problem. If you are a mathematician, you have a problem. So 125, I just made them inclusive. Okay, and this is the condition that and we can club as many conditions as I want. Okay, yes, any questions? You have a question here?
By using this Boolean mask, like,
Right.
we can categorize the data in only two conditions, right? Either in or out.
Yes, yes, it's true, because it's Boolean. You can just drop it or keep it. Yes, yes, true. That's true. Because sometimes you I just gave the example of fraud, but sometimes let's suppose you are working with some other other data, maybe except financial. Let's suppose you are doing something on vehicles, and you are seeing only select those vehicles who overspeeded in the whole day. You have the data for the vehicles who have given the max speed. Okay, maybe let's suppose you are a traffic monitoring guy and you are giving the max speed to the vehicle and when he passed. So you just want to have a threshold. If there are vehicles above 90, I should create a challan for them. So what you will do is you create the Boolean mask. You'll drop everything and keep only which meets a certain condition. Okay, and this is a frequently used thing in data. You do it, I'll say left, right, center, everywhere. If you have data, you have to drop something on a certain condition, you select the data, and that's one of the things that you can do. Okay, but the one necessary important thing is that you should remember here is you're creating copies, not the views. And you know why do we create copies now? Because there is no justified way in which we can just create a view. Otherwise, we have to have more overheads. Now you can mix this. You can mix both of these. You can mix advanced and basic indexing. Okay, so you can select certain rows, columns like this. I'll just give an example where we will mix. Okay, this will be, I think, the last topic of indexing. So I'll just comment out this code and write import. You can mix both of them now. Import NumPy as NP. Okay, now let's suppose I'll create an array. So if I create an array, A is equal to NP dot array. So let's suppose I'll create 1, 2, 3. I'll create a 2D array 1, 2, 3, and then I'll create 3, 4, 5. Then I'll say 5, 6, 7, something like this. 5, 6, 7. Whatever I can do is I can say, okay, create rows like this. Okay, rows is equal to, maybe I'll select 0, 2, something like this. Okay, select row 0, 2. Then I can say from that select all the elements. I can say result is equal and keep this A, and then select these rows, and then comma select everything after that. Okay, I don't need to create columns. So now if I print this, if I print this results, okay, now you can see that it will select these rows and all the things in that. Okay, now you can see it selected row number 0 and row number 2 and everything in that, and that is 1, 2, 3, everything in that. That's 5, 6, 7. That's second row, 5, 6, 7, everything by that. But the most important thing that you can see is we can draw the flags. Okay, and now I think it should be copied because copy has a higher precedence. Now we can see is own data is true. It has its own data. Okay, why? Because we use combination, so it has to copy because of advanced indexing. So that's why it will create a copy of this. Okay, you can mix both of these together. and you can mix even Boolean indexing with the integer indexing. You can have a condition. Let's suppose if you want data from only certain columns and you want only drop from that. Okay, let me just create an example, the same example. If we have this, and what we can do is I'll say select these rows, and then I'll say a Boolean condition. So I'll say condition is, say condition is equal if these values maybe a are greater than say 3, something like this. If I draw the condition, I can write this. Let's suppose, but let's suppose I'll call these columns because I want the data from the columns now. Okay, I'll say based on this condition, based on this condition. So what you should do is only select the columns that I'll say only select these columns. So if you see this, something is wrong. Do I have these many columns? Okay, first I'll check the condition. So there it says result. Okay. I should basically say, so result is equal to a dot condition. So too many indices given for an array because we have columns are 0, 1 and 2 columns are there. See if I just check these columns. I think, why is it giving the error? So are we running the same code? Because you have to literally check the lines. Why is it giving this error? Python test 6.py. So it is saying a condition columns. Too many indices for the array is a 2-dimensional, but we are given 3. Are we giving 3 indices? Is it? Okay, anyways, you can see it, but I don't want you guys to be stuck here. Maybe we can see what the actual problem is, but I hope that you got the concept. The concept was we were mixing the basic and advanced indexing, and the takeaway home thing here is that this also gives you the copy. Okay, is it clear? Any questions on this? Any questions still here? I think with this we'll conclude indexing. Okay, and we'll move on to the next topic. Are there any questions? And there are maybe different types of indexing, but if you know these types, what we discussed so far, and others, probably you can just get a hang of this, because these are the fundamentals, and there are other advanced indexing methods, and I don't feel you will probably need them in your day-to-day life, and 90 to 95% of the times you are done with this and it will be easy for you. And if there are some other indexing methods which are pretty much advanced, and there are advanced indexing methods, and I hope that you will be able to get a hang of these because you have your fundamentals done quite well. Okay, any questions on this? So now what we'll take is we'll take broadcasting. Okay, so what is this broadcasting? So broadcasting basically refers to how this NumPy treats different arrays. So I told you about this. The thing is, let's suppose you give different size of arrays, and you have to perform operations on them. So the point is, how do we broadcast these things? Because the word broadcast itself means you have to cast something. You have to tell somebody something. Let's suppose you got an array which of some size. Let's suppose you have an array of size, let's say this 1, comma 2, something of this sort. This is the size of the array, shape of the array rather. This is the shape of the array. So this is 1, comma 2 is the shape. So now what I can do, if I have another array of shape, just maybe let's suppose 1, and there is nothing. There is just a scalar number. Okay, can we perform addition of these two numbers? Okay, so somehow what NumPy has to do, it has to broadcast. Broadcast basically means it has to adjust dimensions in a certain way so that all these things will make sense. Okay, and this broadcasting, I will take an example for these shapes. Okay, let us start with the first 1D array. So I hope that broadcasting is clear to you. Broadcasting basically means adjusting the shape in order to make the operations compatible. Okay, going back to the code, and I'll show it here. Let's create a new file. So we'll say code test, and this is 7.py. Okay, so now what I'm doing is I'll again import NumPy as np. In that, let's do something like this. I'll create an array a is equal to np dot array. Okay, now if I create an array like this, so this array is 1, 2, 3. So I'll probably create a 2-dimensional array. Let's suppose I'll create a 2-dimensional array. 2-dimensional array I'll create. So now this is 4, 5, 6. Okay, now if you see the dimensions of this, so is there an error? Yes, there is. So here, So if I print this, print a dot shape, so obviously what the shape is, I'll get 2 cross 3. So if I clean this, so I'll say Python test dot, this is I think 7th.py. So if you see, this is 2 cross 3. So if I create an array B, okay, I'll create an array B, that is np dot array. So I'll show you what broadcasting means. So here what I'll do is I'll just create an array of this sort. I'll say of number, let's suppose only 1. So this will be a number 1. Okay, let's again print the shape of B. Okay, see it over here. So this is the first array is 2 cross 3. The second array is 1 cross 3. Now if I want to add them, see the picture wise. If I show you the picture, is like this. So if I show you the picture of this is 1, 2 and 3 like this, and this is 4, 5 and 6 is like this. Now what I'm doing is I have number 1. It's only one number 1. So if this is my array A and this is my array B, somehow can I do a thing like this? So if I can do something like this, let's suppose if I want to add these things together, if I do A plus B, okay, what should basically be done is, so this one should be repeated like this, 1 1 1 1 1 1, something like this, because the size, so that size becomes similar, so I can add this one everywhere. Okay, so this thing, so converting this size, if you just have one, okay, the size 1 comma nothing, so this was this, so it somehow stretched that into this, so it said 1 comma 1 comma 1 1 comma 1 comma 1, so that it adjusted size according to this. The size was 2 comma 3, it made size 2 comma 3 for this. This is called as broadcasting. Okay, and there are rules of broadcasting also. So if I now add this, so let's suppose if I add A plus B, okay, if I add this A plus B, and if I want to print it, let's suppose I want to print it, I can print it like this, print A plus B. So what will happen is, it will give me the result that is expected. So the result expected is add 1 to everything of this. So basically what it did is that I showed you, it did this, it took this 1 1 1, it made it like this, 1 comma 1 comma 1 and then 1 comma 1 comma 1, okay, and then it added these things element wise. Okay, and this is called as broadcasting. So broadcasting basically means to adjust the size such that now you don't require loops. Okay, that's what this, now you have to align them in the memory. Okay, that's what this aligned means. You have to align them in this way, 1 2 3 4 5 6, so that when you align them in the memory, so let's suppose this is the memory right now. Okay, this is 1 1 1 1 1 and 1. Okay, now the next part is you align them in this way. Let's suppose this is the memory, so let's suppose this is value 100, and let's say everything takes 8 bytes. This is value 108 116, this is 1 2 3 4 and 5, so this is 140. This is the memory, and then we have this 1, oops, we have this, oh, we have this 1 2 and 3 and 4 5 and 6. So how to do this with explicitly without loops? So we align them somehow. So by the alignment I say, now it started from 180, let's suppose till some number. Okay, so what it will do is it will take each of these numbers together, so it will align the memory inside, so it can do every operation in a single go without going through the loops. Okay, that's meaning the alignment. Now it aligned it in a certain way, because this is also continuous, this is also continuous. So what it did is, it will not run the loops, it will take this element, add it with this, take this element, add it with this, take this element, add it with this. Otherwise what we had to do is, we had to run through the loops every time if this was just one number. Okay, we'll just keep taking that one number and adding this and continuously, but what it is, it broadcasts it everywhere. Okay, that's one of the example of broadcasting. So but there are rules of broadcasting. The rules of broadcasting is that if you want to broadcast, the sizes, the dimension size should either be 1 or it should be compatible. So what I mean by that, so the rule is dimension, I should write corresponding dimension should be 1 or equal. Okay, what's the meaning of this? Let's see what's the meaning of that. So now if you see this, if I have an array which is let's say this is something like this 2D array, 1 comma 2 comma 3. Okay, so now 1 comma 2, if we put it like this. Okay, now if I print the size, I should not print it, I will print shape of both of these. I'll print shape of these. Okay, the shape of this is, so if you see over here, the shape is the first is 2 comma 3, the shape of first is 2 comma 3, the shape of second is 1 comma 2, this is the shape of second. Oops, the shape of second is 1 comma 2. Now you see this, we can adjust the dimension, because the rule is that The corresponding dimension should be 1. Here the corresponding dimension is 1, but the corresponding dimension here is 2. Now there will be a mismatch. It won't be able to broadcast. Okay, if I just print it, it should give me the error because it should show mismatch of dimensions. If you see this, there is an error. Okay, operands could not broadcast together. You can see with shape. But what if I made it like this? This was 1, 2. What if I made it like 3, 3? Okay, if I made it now, I adjusted dimensions. What I did is the first dimension was the first area dimension has 2, 3. The second dimension, the second area has a dimension of 1, 3. Now the dimensions are equal, and here this is 1. So what it will do, it will broadcast it like this. So 1, 2, 3. It had 1 row and 3 values. So it will broadcast it again through this axis. So it will make a matrix like this. Okay, now it is compatible. These broadcasting is allowed. So if I just add this, so here you can see this, we got this print a plus b 2 4 6 because we are just adding these things because 1 2 3 1 2 3 got repeated. Okay, it broadcasted the value. It made it this. It made this one as 2 cross 3 like this. It repeated them into columns. Is it clear? For how many people is this broadcasting clear? You have to only the rule is that either the corresponding dimension should be 1 or it should be having the same value. Otherwise, you won't be able to broadcast the values. Okay, even you can do it with the multiplication, division, whatsoever you want. I just showed you the addition. You can do it with multiplication. You can do it with division. You can do it with all the operations that are there. Okay, the first broadcasting is like this. If this is, let's suppose 1, 2, and 3, something like this, and we have multiplied by, let's suppose only 2. We have a number 2 over here. So this size of this is 1 cross 3. The size of this is 1 cross nothing. Okay, so what it will do is it will make it 1 cross 3. So it will stretch this. So I'll stretch it like this. This will stretch it like this. It will make 2, 2. That's what we saw. Okay, general broadcast rules are there are only 2 rules. Okay, I should clear this VS Code and then show you it on a separate page. There are only 2 clear rules. So rule number 1. So rule number 1 is that whenever you have the dimension corresponding dimension should be equal, or the rule number 2, or one of them should be 1, or one of them should be 1. This is the rule number 2. These are 2 rules of broadcasting. So when you have to broadcast, you will have to accordingly see it. If you have to, let's suppose I'll now show you another example, and so that it becomes clear. So let me just comment out this code maybe. So what we'll do is we'll create an array A. So A is an array. So what I'll do is I'll create a 2D array. So NumPy array. So I'll create 9 elements. So I'll say array A range of 9 elements, and then I'll reshape it. Dot reshape.
So VS Code is not visible, sir.
Thank you so much for telling me. So what I'm doing here is, so if you can see, okay, this is that. So I'm saying I'll create a NumPy array np.a range. So 9 elements. I'll reshape this, okay, into 3 cross 3, 3, 3. So I'll have a 3 rows, 3 columns matrix. So what I'll do is now I have B. Okay, so then I'll create a B matrix np dot maybe array, and then what I'll do is I'll create 1, 0, 1. So do tell me, will this be able to, if I multiply these two things, if I print A multiplied by B, okay, is this multiplication compatible? If so, why? If not, why not? Can anybody of you give me the answer? Is this compatible? Arshan is saying yes, it is compatible. Why? Because here if you see the shape is 3, 3. The shape is 3, 3. Okay, if you see the shape of this, so shape of this is 3, nothing basically. Okay, 1, 3 basically. So if you see this, it will be 1, 3 because we have 1 row. So now if you see this, the dimension 2 corresponding dimension they match. So if I have to bring it here, so corresponding dimension 3 match, and one of them, the rule number 2 also gets applied here. So this is 1, 3. So this array will be broadcast. So how will it be broadcast? So it will be made like this. So we have this 1, 0, 1. So it will be made like this. So we have this, and then this, this. It will be broadcasted like this. So this will be made as a 2 cross 2 because it is broadcasted along this axis, along axis number 0. So it will be broadcast like this, and they will be added, they will be multiplied together. So now if I just run this, you can see this, it multiplied it. Okay, 1, 0, 1 got multiplied to all these numbers because these numbers were, if I just print also this, if I say print of A. So you can see print of A is 0, 1, 2, 3. Now each of these got multiplied 1, 0, and 1, 1, 0, 1, 1, 0, 1. It's element wise then. Okay, is it clear? Are the broadcasting rules clear? So can you now come up with, if there is something is not getting broadcast, so what is the problem with that? So you can easily come up with that broadcast because there are only 2 rules. The first rule is two of these dimensions, if they have, they should be equal corresponding dimensions, or one of them should be 1. Only then we will be able to broadcast. Otherwise, we won't be able to broadcast. Okay. Any questions on this? The next topic that we are going to study is called as structured arrays. Structured arrays. Okay, what is the meaning of structured arrays? So in C, if you see, there is a struct. Okay, there is a structure which is called a structure. So let's suppose now you have these data files. Now you know that data files, they don't have homogeneous fields throughout. Okay, as I discussed in today's example, that if there is a financial data, so sometimes it will have a CC number, account number. Account number is an integer. So if it might have a location. Location is a float. Okay, floating point number. So it might have a name. Name is a string. Okay, and these are a lot of data types involved in this. What if we can club them together? Okay, so okay, because in NumPy, if you see that, you have this data type. So for that, what NumPy has given is they're called as structured arrays. So structured arrays in NumPy, they basically allow to contain complex records, similar like rows in the database. So we have these multiple rows. Okay, and each of the row has record. It is called as a record or a field. Each of the field has different data types. That is what NumPy allows. Okay, it takes it from the C, because C has something defined as struct. Okay, in that structure you keep fields of different types and then you make it. Okay, so a structure of, I'll maybe define it. A structured array is defined as a set of named fields. It's a set of named fields. I told you what is the motive. The motivation behind that is, as if we have database, and in the database what we have is, we have these records in, let's suppose, in CSV. So each record has different fields, and each field has a different type. So what we do is, we have this set of named fields, okay, where each field has a specific data type. So each field has a specific data type. So that's what this is used for. And then these fields can be accessed by the attributes of the record. Okay, and now how to create those things. Okay, now I'll show you. Basically what we'll do is, we'll create data type. Now we'll say data, then type, something like this, and we'll create what's called a header first, and we'll create a header and define that. And after that, once we're done with that, then we can create. Let's suppose I'm working with people. Okay, let's suppose we have a database of people, and what I want in that is, I want a name, I want their age, I want their height. Okay, this is what I want. And there are a lot of data types that are allowed in NumPy. Let's go to the code window and show you that. I hope that you got the gist of what these structured arrays are for. I'll say code test 8.py. Okay, and now if you see it, now the first thing is, I'll create the data type. So what I want is, I want humans. Define humans. If I see this, so in humans, what I want a name. Okay, and then the other field is, I want their age and maybe height. I want height. Now if you see this, these are three numbers. So name, these are three different fields. Name is a string, or maybe what we use, we say Unicode 10 characters, we have that. And then age is an integer, or maybe you can also use it as a string, whatever you call. Height again is a floating point number. Height can be in centimeters, it's a floating point number. So the first thing what we can do is, we can create structured arrays. So we'll create our own data type. So we'll say data type, something like this. And then what I do is, I'll define it like this. I'll say first field. The first field is name. These are named fields. It's sort of if you see it, I'll create these tuples sort of things. I should not create dictionary. I should rather create tuples. Oops. So this over here. So this is the first tuple. So name. So then I'll say, what is the type of this name. So as you know, type of this name is, it's a string. So you know that there are U32, U10. U means Unicode and less than 10 characters. Okay, that is the data structure, a data type that it supports. Name is a field, and the field's type is U10. Then I'll create the other field. The other field is age. Okay, what is the age? Age is an integer. I'll say I4, which takes 4 by integer. It takes 4 bytes. Okay, I4. Okay, we should have a separate discussion on data types allowed in NumPy. So there are lots. I'll show you the table. Maybe after a while I'll show you the table. So this is name, and then I created an age, and I'm just creating the data type first, because I want records to look like this. And then after that, I create height. Height is the name of the field, and then what is it? It is a floating point, not colon. I'm creating a tuple, so it is a floating point. Let's suppose with again the 4 bytes, floating point with 4 bytes, something like this. Okay, so this is the data type that I created. Okay, now how I can use it with the NumPy arrays. Okay, what I can do is, I can call array as people. I'll create people array, because I want their name, age, and height. Okay, so what I'll do is, I'll say np dot array. Again, the same method that I'll use. Now I'll create elements of the array. Okay, how are the elements of the array? This is how we create the array. Then I'll say first record, and that is Alice, let's say. let's say Mahmood. Okay, Mahmood, and then comma age, let's suppose is some 100 years. Maybe let's suppose some height, I can consider 5.5 feet, something 2.5 or some whatever, 5.5 feet. Oops, 5.4. It so happened. So now I'll create a second record. So this is my first record. Okay. So what I'll do is I'll create a second record. For second record, I'll create the name. Let's suppose we have Asif. Okay. Then let's suppose age is some 150, and then maybe height is some 5'6", something like this. And then now I'll create another record. So let's suppose we have the record for say Sajid. Okay, Sajid is of let's suppose age 50, something like this, and this is 5.8. Okay, so what I have done is, if you see this, I have to import NumPy. That's why it's giving the error. Import NumPy as NP. The first thing is we create our own data type. This is some sort of header, okay, because this was not available there in NumPy. So that's why these are called structured arrays. We created a structured array first. We created a structure. In the structure we had fields. We created these fields, and these fields were named fields, okay, and each one had its own data type. Now if I print people, okay, if I print people, so let's suppose now I'll say Python, create it till here. So Python, this is test8.py. So now you can see this is Ali, this is Asim Mahmood 10054. This is a new data type. If I again check the type of this, so you can see dot, you can say type of this, type of people. It should be a structured array, type of people. So now if you see this class, this is NumPy ND array. This is an ND array of NumPy, and this is called as a structured array because we have given a structure to it. This is the structure. The structure is that there is a name, field name, there are fields, and fields have specific data types, and this is how you can write. You can say Unicode 15 also. Okay, if it exceeds 10 characters. Let's suppose if it exceeds 10 characters, I'll see what will happen. Type should be deleted. Okay, it still takes it. Okay, Unicode 10 basically. I did exceed 10 characters, and you will have to see specifications of this. I was assuming that it should not take, but it takes it. But I hope that I got the point through. So what are these structured arrays? The structured arrays are nothing but they are advanced type of arrays by which we can handle this structured data. We give a structure to it. Okay, let's suppose I give a real world example of people. Let's suppose you want to create an array in which you have people in which they have name, they have an age, they have height, and maybe other fields also. So you can create these structured arrays. So what are different components? The component is, so I'll just write over here. Oops. So what are the components? The components. So components are, the first component is field elements, the field names. Sorry. So field names is the names that you give in the fields. Let's suppose you gave name. Name is a unique thing. Let's suppose you gave some other thing. The header in the column, that's a field name. Second thing, you give data type. Data type. So the type of the data that you have. Then you also sometimes give what's called as field offset. Okay. So field offset. What is this field offset? So field offset basically tells you the where fields can be positioned at different byte offsets, as we saw that stride. So you can do the offset. Okay, this is that field. This field takes this many bytes. Okay, and after this, if you want to move to the next field, so you have this field name and field data type. So you can customize it, and you can say, okay, next field starts from this offset. If let's suppose the first field starts from 0, so if you just move, let's suppose 50 bytes, so after this the next field starts, and you can specify these offsets also. Okay, how can you access this now? And you can do the same indexing that we saw. You can access it in the same fashion. Okay, right now let's suppose this is people. So if you want to access it, same index. If I want 0th record of this, okay, 0th record, that's similar like index. That's why I taught indexing first. After this I taught this. So now you got the first record, Mahmood 100. If I want his age, so Mahmood 0 of 0. Okay, so if I take this, so this is Mahmood. If I want all the names, so if I want all the names, so I should select all these rows and then just select the 0th column. So this should give me all the names. So if you see Mahmood, Asif, and Sajid. Okay, this is again the same indexing that we saw, but now we gave it a structure, proper structure. Okay, we can have individual, and one more thing what you can do is, if instead of this you can just type the field name. That's more important. You can just type name. So you can type name, it will give you all the names. Oops, there is a problem. I need to see it. So it says people index only. Oh, integers are defined, but I hope it should take it. Why is it not taking it? Print people name. Oh, why is it not taking it? Let's suppose maybe the documentation that I'm looking is maybe for something else. Age. No, index only takes integers as slices. Maybe it takes only integers, so you'll have to work with integers. Okay, but I was supposing that it should take them. Okay, this is the additional functionality. So age of 1, if I take it like this, no, nothing happens. I'll see. No, I think we have to live with that indexing only. I was supposing that they should have given functionalities, so this is an open problem. Now what you can do is, if they have not, so you should access the individual elements by yourself. You should write additional code and push it to GitHub, so that if you just want, let's suppose, names, and you can just give the field names. Okay, but you know that basic indexing, you can just basic index it. Is it clear? Okay, this is how you can create these structured arrays, and based on this you can also, now what you can do is you can apply different sorting mechanisms. So let's suppose you want to order these people by age, you can sort. Okay, let's suppose for these people you want to sort them by the age. So what you can do is sorted, let's suppose I'll write sorted by age, something like this, sorted by age. So in this what you can do is you can write np.sort, it's a function. Okay, I suppose it should then I'll write people. Okay, and comma, order is, yes, order is equal to, then I'll say age, by the order of age. Oops. These are additional functionalities that it gives. Okay, if I now print the sorted one, so I'll print this sorted one. If I see this, again there's a problem. Cannot specify order. Cannot specify order when the array has no fields. It has fields, but okay, is there a problem with this? Data type, oh, okay. I missed one part. I have to type data types here. Data type is equal, so I'll type this. D type is equal to data type. This is what I missed earlier. Okay, I have to give this data type explicitly because this is what I mentioned. Oh, yes. Yes, now it gives. Now it should also give me the other features. Okay, and the other features are, which I said, if I want print people of, let's suppose I want names. I want names of all the people. Yes, beautiful. Yeah, because I missed this D type. Okay, I was assuming I just wrote it. No. So this is the D type because I created this data type first, and then I created this. I said people of name. Now that this is how you can access it. And I was thinking you have to create this functionality. I was actually reading the right documentation, but I had missed this D type. Okay, now if you see this sorted by age, I said people and order is age and sort by the age. And if I just print this, you can use the other methods also in here. So look how much flexibility it gives. You can create your own data type now. You can create your own NumPy arrays. Okay, but only thing is you have to first create your own data type. These are called as structured arrays. Yes, somebody had a question. Was there a question? No. Okay. So how many of you understood these structured arrays? And you also understood the notion why are they used? Okay, because in order to create complex these things, because we are dealing with data sets here. So every data set probably will be with numbers, strings, and everything, and you can create your own data type and then have them in the structured arrays, and then it gives NumPy gives a lot of functionalities. Like right now, I showed you, let's suppose this NP sort, and there are other things like you can filter people also. So you can say something like this. So we have this people. So I'll say people, okay, off, and then go to the people and see age, see people's age, and if it is greater than, let's suppose 25, then only print them. Let me be 35, and everything will get printed though, because everybody is having the age of that. Okay, so let's see this. So this is showing Mahmood. So if I decrease the age of somebody, I'll say 18. I'll say maybe whatever this is, and then it'll filter also. So you see this, it just gave me Mahmood and Asif. Okay, I should just comment this out. It rather gave me Asif and Sajid. These are the two things that it gave, and this is called as filtering. Now I filtered based on something. Now see how much power these structured arrays give you. You can create a data type of your own, and then what you can do is with that you can create your own data. But do mention, as I forgot here, so D type you should put this as data type, and then you can access each of the field, and you can have a lot of other functionalities. Let's suppose here I sorted the things. I did a conditioning. I said okay, select only those people who have age greater than 50. I can sort based on these fields. I can do the operations based on these fields. Is it clear? And you can add new fields also. Okay, if you want to add new fields, you can just say this. You can create new data type and then just change the Z type, and then you can also copy existing data. So let's suppose if you want to create people, just say people and a name, and you can say let's suppose you can change the fields basically. So change fields and go within each field and change the data also there. Okay, and there are a lot of methods, and there are a lot of combinations you can do, but I hope that you got the gist of these structured arrays. So just last point, so structured arrays are used because this we have limited data types and we wanted homogeneous elements throughout. Okay, that's what gave the power to NumPy, but there is a necessity when we have data types, each of the field is of different type, so each of the features rather is a different types, which they are called fields here. So it's inspired from C language because C language has a struct. In that struct, we define these fields of different data types. That's why we did it here. So we define data type with a field name with a field data type. Okay, and then we created the NumPy array as we used to create, and then just added this data type d type. Is it clear? Can I assume that you understood this? There are a lot of things, there are a lot of methods that we can discuss on these structured arrays, but I hope that at least you got some hang of these structured arrays. Okay, so with this I'll conclude today's session. I'll stop recording here, and the recording is 2 hours and 20 minutes.